we're gonna do more electrical stuff, but hopefully it goes better because last time, holy crap. It was, we had some issues. We had some issues. Hey, Kick, what's up, dude? Alright, that should be good on the YouTube side. I shouldn't have closed that, though. Hey, Code Dungeons, what's up? No bylaws? Nice. Okay. I think we're good. Should I consider... So, like, this could be the title for, like, the VOD, but what should the title be for the stream itself? Like electronics testing with Arduino Nano? I don't even know. What did I have it as? Creating an RC transmitter using Arduino. Let's do that. We'll do the VOD title later, but I want the title to be a little more appealing. Testing components for their... Okay, how about that? All right, cool. All right, and let's make sure Twitch isn't a dumpster fire. I didn't know you streamed. Is this new? I mean, relatively. You can check out some of my other streams. It's new as in, like, I haven't streamed in a while. How do I go to my channel? Oh. So, like, I've streamed, but these are all my past streams. This is part 4. That's a much better title. So, we're working on it. And sorry about the printer noise in the background. I'm sure you can hear it, but I'm printing knobs for my Rotary encoders that just came in.
Are you streaming?
I'm live.
You're live?
I am alive and live.
Oh, okay. Did you just start?
Yes.
Oh. Okay, well, I'm gonna go to bed.
All right. Good night. It's so early. Bye.
Bye. Love you.
I love you too. Good night.
So many wires.
They're organized. They're very organized. I'm gonna turn down the music just a little bit. All right, So where did we leave off? Let me show you. We have, if this wants to turn on. One second. Cool. Okay. So we've got this. It's literally just a rotary encoder and an Arduino Nano. But before that, the first thing we got working, aside from the Arduino Nano, I'm gonna take my headphones off. The first thing we got working was the NRF chip with the antenna. That was annoying, but we got it working. So now that we've confirmed that that works with the wiring setup that we made, which is this, it's time to like test the actual components of the controller, because like the NRF doesn't really matter. And the first was the rotary encoder. So this is wired up how it should be, but it's using a breakout board, and that's not the actual rotary encoder I'm going to be using. And the actual one is this, and it came in today. The knob, that's what I'm 3D printing. I'm 3D printing the knobs, trying to get a good size for it. But there's your rotary encoder. Here's the bag of rotary encoders. Don't really need all of those though. I'll put those. I'll organize everything eventually. You sleep at like 9, but what happened with the Arduino? We got it working, dude. Hey, Bondrew, what's up? Shall I go on Twitch for my name? I mean, dude, just change your YouTube display name, please. Drives me insane. You're like 3 different people. So we got the rotary encoder working, and let me just demo that really quick. Although this is probably not going to work yet. Hold on. Yeah, no, this should work. Oh, wait. No, hold on. I took out the chargers, so there's no ground at the moment. I want a smaller wire than that. It's too big still. This is perfect. So I just want to link up the Arduino's ground with the breadboard's ground. Try at least. Well, that wire was not the ideal length. Hold on. Probably would have worked how I had it, but there we go. Okay. So this bottom track is now ground for everything. Let me just upload not this code, definitely not this code. And I've also decided I'm going to try, so all these tests, I'm going to try to write the code in a way where at the end, like once I finish testing everything, I can just like put it all together. So I'm actually going to edit this a little bit, but let's upload the code. It'll work. Hopefully. Jesus. All right. And then we can go to the serial monitor. So here's the code right now. Okay, it's not working. Why isn't it working? Because this isn't the code. This isn't the file. I don't know why I thought it was. Open recent, let's go to main. I believe I called it main, which is going to change. Yes, this is the code. Okay. And just to show you guys where it actually is located. It's not RC code. I guess it's like test code. It's currently in, yeah, it's currently there. I don't like that. So let's name it Rotary Encoder. I don't think. So RC code, this is going to be I really need to organize this. Let's go with RCV1. RCV2. Okay, this is better. Okay, now that the files are actually organized, you guys couldn't see any of it. That's awesome. That's awesome. My bad, but I guess you didn't need to see any of it. You know what, let me just show you. Sorry about that. It is now organized into RCV1, which just has that. And RCV2, which has the rotary encoder knob in the STLs, and then the code, rotary encoder, rotary encoder. We'll do it in a way that makes more sense. It forced me to put it into a folder like that, but what I actually want is to have like multiple pages. So I guess, well, I guess we'll start that now, right? So let's start that now. Really quick. I want to, what do I want to do? I think I want to make a new sketch. And we're going to save this. Here. Under code. And then just put it all here. Let's save it here. Name it main. This is the main sketch. Now, did it? Yeah, look at that. It forces it to be in a folder. That's fine, though. That's fine. So we have this. Now, what I want to do is, like, add this as a new, like, page. And I think I can do this. Yeah, new tab. This is going to be rotary encoder. Yeah. Oh my god. Okay, and now this entire thing goes here. We'll fix. There's a loop in this. So there's like multiple loops. I don't think that's gonna work, but we'll see. Do I have to include this page into this? I don't even think I can because there's this loop. But okay, regardless, I do just want to demo this really quick, so let's upload it. I guess I have to do this again. Okay, you guys can see this? Yep, so when I spin it to the right, it says spun right. And it says that for every click I spin it. Spin it to the left, it says spun left. And then if I click, it says switch pressed, switch released. So the code I wrote senses this perfectly. Ignore the debounce stuff. It was just for testing. But that's kind of where we left off, right? So next I want to basically make a master sketch kind of thing, make like the actual RC code and incorporate this rotary encoder stuff into it. So let's think about this. Like I have a feeling this. Jesus, do I have to do this for every new sketch? I guess so. Like, I'm curious what happens if I just upload this. Yeah, see? So okay, so the tab automatically is added to main, but is the music even playing? Oh, okay, new song. But it can't have multiple setups, right? Which is fine. Which is completely fine. How do I guess I can do this. Void set up rotary cover. And I mean, maybe with this we can say like what pin is what, but that would be kind of fancy. Although, I mean, I'm also fine with just hard coding it here, to be honest. Yeah. All right, setup. Oh, I already put it there. So we don't need that. And we're just going to call this setup function for the rotary encoder in the setup of our main script. Now to deal with the loop. This is where it's a little bit interesting. How do we want to handle this? Basically, I want to read this and then output what has happened, you know? Yeah, sorry guys. I changed it though, don't worry. I think you can try like literally copy pasting the .nano file. I don't know. I mean this worked out, so. Hey Boston, what's up? Grambo. You've seen all my bot vids? Nice. Yeah, hey, thanks for stopping by. You get to see me actually working on the remote control. Okay, how do I like so I'm thinking there's just a function I call in main that reads the state of the rotary encoder. That's my thought. I'm not sure if it'll work. I think it'll work. What do we want? What do we output? We could output like an integer or a struct or something. If let's say we output an int. 0 would be nothing happened, 1 would be pressed in. Two could be it was just spun right, 3 could be it was just spun left, something like that, but I'm not a huge fan of that, to be honest. It's tough because like I'm trying to predict how I want to use this in the future. So like in main, I'll be constantly calling this function and seeing what the encoder does, right? And then I'm going to use the return to do stuff in main. Yeah, let's make a struct. I like this for now. Yeah. Yeah, let's do that. It'll be in here. The struct will be hold on, how do I don't even know the syntax like at all, so is a struct what I want? No, I don't think a struct is what I want. Never mind. I want... Oh, maybe I just want constants. I want to be able to, like, type a word. And have it be represented... And have it represent, like, a number or something. No, this isn't what I want. Never mind. Wait, oh my god. Let me look at... I'm pretty sure I did it in my code. I completely forget... what it's even called. This is the hexapods code. It's an enum! That's right, enum, yeah. It's an enum. That's what I meant. That's what I meant. Rotary encoder, action, state, event. Let's do state. Nothing. Pressed. Spun right. Spun left. So I want to return a rotary encoder state, basically. I have no idea if this is gonna work. Maybe I just I might need to return an int. We'll see. Can you press it in and also spin it? I don't want that, actually. I don't want you to be able to press it in and spin it. That's stupid. So if you're pressed, spinning isn't red at all. Let's try this. Or do you have to do like rotary encoder state dot pressed? I actually don't know. I don't remember. No, you just type it out. You just type it out. Alright, that's nice. I think Make Your Pets requires a cell phone too, but still, yeah, his is gonna. That one he made is insanely cheap using the 996s. You've been considering doing a project with a drone or hexapod, but you don't have a you don't have a 3D printer or any experience with CAD. Okay, let's settle down here. You have an embedded experience. That's good. Do you have the money for a 3D printer? I guess that's the first question. You have an embedded experience and quite a lot of programming experience. Okay. Okay, wait a second. No, I think you can handle this. Okay, you're just a high school student. Never mind. How do you have quite a lot of programming experience and embedded experience as a high schooler? That's impressive. Although it's all relative, so I don't know. Yeah, I don't think a hexapod is a great project for someone like you. Like, I'm able to do this. I'm actually in a I was in a similar situation. Like, I had a ton of programming experience. I had a decent amount of electrical engineering, whatever, experience from college. I had 0 CAD experience. I had Blender experience. I had some 3D printing. I knew enough about 3D printers to do whatever I wanted, basically. 3D printing. So, but the difference is I had a full-time job and had money to, like, buy stuff. So I really don't think this kind of project would be good. I would stick with, like, especially for your, like, first thing, maybe like a robot arm or something. Like, just 3 servos, super simple. I think your first thing should be a 3D printer, though. That's kind of important for these kind of projects. Oh, you're in middle school. Nice. Hey, Pierogi. Oh my god, your name. It just makes me like misspeak every time I try to say it. Oh, that's a good idea. Yeah, Pierogi, if there's a makerspace near you, that's a good point. Since you were 9, oh my god. That's awesome. Wow. Dude, I was programming like Lego shit. That was pretty much my first kind of programming stuff. And then I just made, what did I do? I made like an Arduino, no, Jesus, an Android app just for fun. But yeah, you're working on the weather balloon thing? Nice, that's cool. You don't think you have the money. Yeah, that's the thing. I was like, dude, I've spent so much money on servos that I'm not going to use for the foreseeable future. I will find a use for them, but a hexapod is definitely not a great project if you don't have a decent amount of money. Yeah, Lego Mindstorm is kind of expensive. I mean, you could try to make a hexapod with M996s, MG996s, the super cheap servos. But again, like, you don't even have a 3D printer, so it's like you should get that first. Start small. Start small and work up to this. Okay. Because the reason you could start with a hex file. That's what I did, but I'm not being hypocritical. The reason I'm saying start small is because you don't have the money to do large projects like this. It seems. Yeah, I mean, and the chassis from AliExpress. Yeah, you could definitely do that. You could definitely do that. Yeah, no problem. You're welcome. Right. Okay, so I returned this. The function is this. If it's pressed, return pressed. If it's released, should I return released? I'm gonna go with yes, actually, because I don't want you to. So theoretically, if you press it in, it'll be pressed, right? And then if you hold it pressed in and start spinning, it's gonna return other stuff. I don't necessarily want that. So we're going to have a new state called released. Okay, that's good. And then keep in mind if this returns, none of this code is going to read. But that's fine. I don't want it to. All right. Right here. Spun left. Return. Spun left. Do I have to put the enum in main as well? I don't think so. But we'll see. Kind of want to just put all of these enums in main, so I can see them, but it's fine, I guess. Let's just see if this. I don't even think this will work because it doesn't know what this is. Yeah, frick. All right. Okay, I guess we can try putting it in main and see what happens. Oh, whoops, sorry. I always forget that. Wow, all right. That just fully compiled. Cool. If Rotary encoder state does not equal nothing, serial.println. Now, if we print the Rotary encoder state, I believe it's a number. It's gonna be yeah, see, 0, 1, 2, which is fine. It's just not ideal. But regardless, let's just see if this works. Because, I mean, this is much cleaner than this. But this is all just hidden, right? This is just a function we call now to get the current Rotary, to get what happened with the Rotary encoder. So I envision there's going to be just a bunch of, That's not what I envision. There's gonna be like... Jesus Christ. Like what? It's gonna be like a bunch, just in this loop, in the main loop, it's just gonna be a bunch of lines getting the state of all the inputs. And then I'm going to use those inputs to navigate the menu, to like change the menu and stuff. And to control the hexapod, of course. But anyway, for now we just have this. Let's upload it one more time. So the output should now just be a bunch of numbers. Hopefully. Okay. Oh, shoot. Okay, I'm never setting the state to nothing. Wait, how is this even working? What? So this is 0. It's state... Right now it's a bunch of state 4, I think. Spun left. Because it's the state... Because I'm not setting this, it's just grabbing the state that was in the memory of this variable or something. Okay, I messed up. I need to, if none of this happens, I need to return the word, I need to return the word nothing, okay? That's hilarious. I think. That's just a funny thing to write. Try that. Hey, the 3D printer finally stopped. So the music is actually slightly louder. All right. Hey, Maldark, what's up? Would you implement ROS in your robot? I haven't had a need to at the moment. I've thought about it. I had an experience. I used ROS in college, and I did not have a good time with it. It was just like really confusing. Granted, I had no idea what was going on. Still don't with ROS. That is. So I don't know. I mean, I want to code a simulation on my own. So we'll see. Hey, it's not spamming. Okay. Look at this. So look, it's outputting 3, 4. Okay, that's not good. And there's no release. Okay, so let's think about this. What I wanted to happen was it only outputs it one time. But I was holding it down, and that's what was happening. So let's think about this. Oh. Okay. All right. Yeah. I wonder if anyone caught that. If I'm returning, the rest of the code doesn't run. So no shit that it wasn't working. All right, let's try it now. So if I press in, release, there you go. This works really well. All right. My fear is that it might not, the more code we add, the worse it'll work. But I mean, for now it works well, so. We will see. I'll just comment these out. Or maybe So let's do something like this. We'll make an enum or a const. Jesus. We'll make a const called debug print, and then if debug print. So if debug print is false, this will not print. If anyone knows a better way to do this, let me know. But this seems intuitive to me. Right, so putting this here means that this can't see it, which doesn't make sense to me. Did I do something wrong? Do I need to do like const bool? Ah, yeah. My bad. So it's false, so nothing should print except the number now. Yeah, there you go. Cool. This is just to help me know, because like what these numbers are in the code. Although, do I ever need to know what these numbers are in the code? Like, without counting them out, I can just quickly glance up and see. We'll see. Okay, I'm pretty happy with this. We made a little interface API. I don't think we can call this an API, but so we can call this, and it gets our state, and then we can use that state to do stuff, right? Now, let's use this. Although, okay, I just printed some more knobs. Hopefully one of them's better, because the one I had I didn't like. You're literally making a remote in your PC for your robot to use it with Ross. That's awesome. All right, I printed a bunch, all different sizes. So hopefully one of these fits. Well, they should all fit. Hopefully one fits well. Okay, that's not horrible. Ooh, I think we have a winner. The problem is, I don't know which is which. Jesus. Well, I guess I know if it's too small, then it's one of the smaller ones. I need the I didn't design this, I just found it, by the way. Ow, I'm bending the pins too. Okay, I don't like this one. So these two seem good. So the two bigger ones. Okay, this is the biggest one. This one. The second biggest one is what I want. Perfect. All right, so let's hook this up, but with the rotary encoder that we're actually going to use. I'm not using the breakout boards. So here we go. Trying to get comfortable. Let's see, really quick. Or, well, I guess I'll have this up. That's a perky switch you got there, son. Oh, boy. What's up, Arnavid? How's it going? So, where is it? Here it is. Now, it is going through a shift register, but we're not doing that yet. The switch... has a resistor, and then we have 2 more resistors for A and B. B, and they're both going to be pulled up. Interesting. All right. This is what I'm looking at right now. If this decides to work. Oh, it's not working. Hold on. Okay. This is what I'm looking at right now. This is the rotary encoder, and this is like the actual one. So the initial one, the one I had working was using a breakout board. Thanks, Progy. Have a good night, man. I'll see you later. You're on a large amount of illegals. Jesus, okay. All right, let's get our resistors and see if we can do this. So these are a bunch of 10K resistors. It's on, what pins is this on? Well, I guess we'll figure it out. Let me know if the music is too loud or too quiet or something, because I can't hear it right now. Obviously. It should be able to fit in between here pretty nicely. It's a little tight. I'm gonna bend these. I'm gonna try to. Jesus. Yeah. I'm gonna bend these little things out. Uh-oh. Did I? I just pulled. Oh no. What did I do? There we go. Okay, well that's good to know, I guess. I'm gonna bend those out and then try to connect it. Oh, I see. The pins just don't... I didn't need to bend it out. It's just the pins aren't going in nicely. Okay. That's good to know, I guess. I mean, it doesn't matter. It's just annoying for this. What about this side? Not... It's annoying on both sides. Alright. I guess we can use these. Does this at least... And of course these don't. Of course these don't grab it. I could solder some pins. That's kind of annoying though. Oh, that's super annoying. Is that what I actually have to do? Does it really not like... Frick. I mean, this breadboard is like really tight. All right, I'm gonna solder some pins because I have to. I don't know what else to do. Sorry I can't get a camera over here, but you know. Oh. I mean, I guess I could get a camera over here. I didn't really plan on doing any soldering this stream, though, so sorry. We'll try. Let's see if this cord is long enough. Are any of my cords long enough? Well, not really. Here's what we'll do. I'm just going to point it in this direction. There you go. You get to watch me from afar. Oh, we can even zoom in. Sorry, my cords aren't long enough, but this is this is as good as you're gonna get, so alright. Let's see here. Bam. Now the other side. You know what, let's just make sure this actually fits in the breadboard first. Or if I'm wasting my time. Oh yeah, baby, that fits. Fits like a charm. How well can you guys see this? You barely can see it at all. It's okay though. Not bad. Not bad. This was the side I just did. So now, hopefully, I can put it in the breadboard. It doesn't really matter. Oh, yeah, there. That's the stuff. That's the stuff right there. Oh, baby. That was easy. That wasn't even hard. Wagon, we just soldered some pins to the new rotary encoders that came in today. And we're gonna wire it up. Oh, this is not the angle we had before. Okay, that's probably fine. The tape I have here is supposed to be so I knew what the camera limits were, but it's all messed up now. That's fine. All right. So according to this, the far left should go to ground. So let's do that. Do we use jumpers or do we, I mean, here, let's use these for now. And then we'll finalize, once we know it works, we'll finalize it with like real wires. So this goes to ground. The middle one goes to ground. Okay, now I'm confused. Oh, sorry, this doesn't go to ground. I misread it. This goes to one of the pins. The middle goes to ground. The other goes to the other pin. Okay. So this goes to, well, what pin did we have? I don't remember. It was pin 5 and 4. Clock was 5, DT was 4. I have no idea which is which. So let's just put this to 5, I guess. So that's D5. It's just not going in. All right. D5. And then, man, all I have is like insanely long jumpers. Let me, hold on. I'll be right back. There we go. All right, I got more jumpers. Shorter jumpers. And okay, so the middle goes to ground. That's simple enough. And then this one goes to D4, I think is what I said. Okay. Now we need the resistors though, apparently. Oh, we'll see. I'm not actually sure. So, well, let's see what happens. So I need a resistor that goes from A to 5 volts and from B to 5 volts. So these are some 10K resistors. Now this, yeah, okay, this is fine. Let's permanently make a track over here 5 volts. I want a smaller wire. I say permanently, just what I mean is I'm using like the nice wires. Do this. So 5 volts goes to the plus like that. Okay. That might be kind of far away. We'll do it on the other side. Oh, well, okay, god damn it. Will this reach? Wow, that's probably perfect. Oh, it's so close. Oh my goodness, it's so close. Come on. Damn it. This reminds me of the stuff I did in college. Okay. So 5 volt goes into here, it also goes into here. We want a resistor going from A to 5 volts. Man, it like feels like it's not even touching the metal, but I'm pretty sure it is. And then we want another resistor going from C to 5 volts, and or B, I guess. And I know you guys can't see it, but oh, actually, let's see what actually happened here. Yeah, ground is in the middle. Here's A. Yeah, okay. And A, yeah, then A and B need pull-ups. Yeah, exactly. Hey, Lombax, what's up, dude? Good luck, gamer. Yeah, the City Skylines. Did that just come out? Dude, Lombax, I just built a new PC, like, last weekend, and I am itching to play a game that actually utilizes the new CPU. Dude, I've got to check that out. Ugh. Uh-oh, it's getting shoved all the way down. Okay. Resistors with breadboards don't feel great. This might work. But I feel like there are a lot of things that could go wrong with this. A lot. But let's try it, I guess. See what happens. See if it explodes. Okay, no explosions. That's good. I mean, wow. So the switch doesn't work because I didn't wire it up. Okay, one thing that's interesting is one turn is triggering twice. Huh. But the breakout didn't have that. Okay, I mean, just curious. What happens when we swap the pins? So that's... Or, I mean, it's very possible I got the pins correct on the first try. Okay, do the pins not matter? I am so confused. I mean, we're still getting that issue of, like, double. Why don't the pins matter? he made a rotary encoder that included a 7414 and a few extra parts to debounce the contacts. That's cool. What is... He made one, like, from scratch? Wow. So... Do the pins just not matter? Maybe they just don't matter. I guess it's just 2 switches, right? Let's print some debug messages. So I'm spinning it right. Oh wow, it's triggering a lot. Okay. I mean, it just triggers twice. But I thought we stopped that. Because, like, we're counting. We're already counting 2 spins. So does that mean it's spinning 4 times? Okay, and then let's switch the pins back because apparently... Well, I don't think it even matters. I'll re-upload the code too, who knows. Try putting a capacitor. I could try. I don't really want to. I can definitely try though. I don't know why, but Python is somehow much harder for me to read than Rust. Nice. That's funny. Python's like the easiest language to read. It's like almost English, right? Oh, okay. So the only thing, it's just reversed now. Oh, that's interesting. How did I not notice that though? So spinning it left now triggers the, okay. But yeah, if I understand correctly, it's just 2 switches, right? There we go. Do you really think this is debounce issues? Like it's. Well, let's try to get the switch working at least. So we want another 10K resistor, 5 volts into one end, the other end into a pin. What is that pin? 6. So I can show this. Why not? Oh. List set. Are you making a list? Dude, wait, I don't even know. That's so confusing. I have no idea. I don't even want to, I don't even want to try to understand that. All right, oh, you guys can't see this. Now you can. So I want to, what if I zoomed in a little bit? Would that be more interesting? you might not be able to see it as well, but at least like, or as much. You wouldn't be able to see as much, but at least like you can actually like see it now. Okay. Well, sort of. Let's do this. So we're gonna put this here. So this will go into the pin. I said D6. Yeah, maybe this will be cooler to watch. And then, oh god, did I say it goes into power? I don't remember. Yeah, it goes into 5 volts. All right. So let's grab another jumper. This gets put into 5 volts, which is just right here. And we're also pulling something. Okay, and then, oh crap. The pin one, we need a pull down resistor. So that goes to the pin. So this needs to go to ground. Ground is not currently linked together. Let's change that. This is fine, I guess. Okay, so ground is now linked in a wonderful way. So this resistor we want to go to ground. Okay, let's try it. Can't really upload when it's not plugged in. Try putting that in the chat GPT. That actually, and have it try to explain it. That might help. Unironically, like that actually might help. Okay, so already it thinks the switch was pressed. That's great. Oh god. Okay. Okay. I think it's because I think I know why. So I made the switch pin a pull-up. I just want it to be an input. Because I'm manually pulling it down. And then if the switch... Okay, it still doesn't work because... something... Because I know now that if it's pressed, yeah, me just touching the wires making it freak out. I'm obviously doing something wrong. Normally, so I don't normally do buttons with like resistors and shit. I always do the input. I always pull up the input. Oh Jesus! All right. If switch value's low, doesn't that mean it's pressed now? Or I'm gonna have to look this up. Hey guys, what's up? Oh god, did someone just raid me? Sorry, if someone just raided me, maybe not, but like a ton of Twitch people just joined. I don't have any notifications set up or any, you know, alerts set up. So, okay, I really appreciate it. Thank you. Who raided me? I have no alerts. What's up, Argentina people? All right. Echo Party. Hey, thanks, man. I really appreciate the raid. How's it going? We are currently trying to wire up a button, but I swear, maybe you can help me. So I'm working on all of this is going to be for a PCB for my RC controller, and I'm just going through every component and just making sure it's working. So I have, in the last couple streams, we made this schematic, which is wonderful. it's just a nano with a screen and a bunch of inputs, basically. And then stream after that, we made the footprint. I printed out the footprint. Looks good. And now we are, before like ordering it, right? We're just making sure everything actually works how we think it does. So, so we're wiring it up as the PCB would wire it up, and yeah. So yeah, that's what we're doing. And right now, I am trying to get our rotary encoder switch working. We got this one working, which is a rotary encoder switch with a breakout board. But I'm not using that, right? It was just because like I didn't have the actual one we were using at the time, but now I do, so I'm trying to get that to work, and that's where we're at. You're all caught up. If you want to see the I mean, you can kind of see it in the background, the hexapod. Right there. It's a little blurry. Don't mind that. But if you want to see it in the in below to the left, there's a link to my YouTube channel, Acert Robotics, and I mean, just click that and you'll see videos on it. But, okay, rotary encoder circuit on Discord. Yeah, oh, on Discord. Oh, nice. Okay. Where did you put it? Okay, definitely put it in stream chat. But this works too. Okay. Okay, this is more complicated than I expected. Do you want me to like make this? What are all these and or not gates or something? What the hell is this? Oh, should I just look at this? Okay. So I don't need resistor? Oh no, this is dude, what? I don't even know what I'm looking at. Cool stuff, thanks. You are a hacking community who likes hacking things. All right. No pressure. Oh, what's this? Oh, shit. Okay, your eco party. Nice. Cool. Oh, I don't speak this language. Okay, Argentina. Yeah, Argentina, fair. Oh my god. All right, this is you. Hell yeah, dude. I want to see like pictures. Eco jobs, dude, you've got your, oh my god, this is awesome. Well, no, let's get to know your story. Okay, you like hacking things and you're into cybersecurity. That seems at odds, but fair enough. I guess for good cybersecurity, you need to know how to hack. That does make sense. Cool. I could read all this, but I'm not going to right now. That's really cool. Actually, I'll keep the website open though. Okay, electronic knockout party. Nice. There are 2 parts. Look at the second pick. Yes, I'm looking. Okay, guys, I don't care about debouncing. I just want it to work. Okay, I really don't care. I don't even like. I don't even know what this is. A button? Oh, is this the internals of it? Of the rotary encoder? Okay, this is Jesus Christ. We're gonna do this. We are gonna do this. My camera overheats if I don't turn it off. All right, we're gonna find a rotary encoder tutorial that doesn't use the breakout board and see what they do. Yeah, we don't want this. Although, I mean, if I set mine up to be exact, I mean, the breakout board only used 2 resistors, 2 10K resistors. You'd think that if I set mine up the same way, it would work. Okay, clock and DP. When you twist the knobs. I don't care about that at the moment. It only changes state. Oh, 42 viewers now. Wow, oh, you guys had a lot. All right. Nice. Yeah, guys, definitely check out my YouTube channel, Acert Robotics. I'm making a Hexbot. It's pretty cool. Also, in my Discord, if anyone wants to link me a tutorial that I can follow for this, we're working on it. My specialty is programming, okay? Oh, God damn it. I mean, I guess if I can just copy the breakout board, it would work. Is it EC11 or ECE11? I don't remember. It's EC11. Finally! Holy moly. All right, here we go. Here we go. Oh, you just shove it right in. You don't even, okay, but, So they probably are going to pull these pins 2 and 3 up or something. Oh, isn't that the interrupt pin though? I don't want to use the interrupt pin because I'm not going to be able to. Oh, here, okay. Two coding pins and one ground pin. Do I have the ground set up correctly? Yeah, I do. I mean, this guy... Really? You don't even have any code? You just... Oh, it's EC11E. This is annoying. Like, I want to get to the fun stuff. I want to get to the screen that I have. Where is that? Where's my screen? Where the hell did I put it? Am I going crazy? Oh, here. So like this controller, it's gonna have a screen. That's gonna be interesting to do, but just like these freaking buttons are so annoying. They're so annoying. Okay, it's fine though. I'm gonna try to just copy. I'm gonna try to copy my breakout board because I think I already looked at this. Input pull up, input pull up. They're all just pull-ups. Okay, I guess we can change it to that and see what happens. Well, change it back to that. But my wiring is definitely not correct. If I'm setting this to a pull-up, that means the pin is normally high, right? So shouldn't my resistors... This isn't gonna work. Yeah, it's free. It's freaking out. Does spinning it at least work? Yeah, spinning works, sort of. Okay, this should not be this difficult. It's just a button. It's literally just a button. the thing is I'm trying to copy the wiring that I did. So here's the thing. I want my button to go through a shift register, but I don't actually have the shift register yet. I have it, I just am not using it yet. I mean, if this was a button, I would just connect. If this was a normal button, no shift register or anything, I would just connect this to ground like that, no resistor, and then make pin 6 an input pull-up. Switch pin 6. So, I mean, this should work, right? It's just a button now. This is how I personally would just normally do buttons. So pressing the wires doesn't do anything, and yeah, okay, so that actually works. My spinning left and right still are doubled up, which is super weird. All right, let's take a look at this. So I'm actually good. The camera might actually help me visually see it. This is the breakout board. You can kind of see. Oh, it's really hard to see. You can kind of see the wires when I get the glare on it correctly, but just take my word for it, I guess. So the middle pin. Middle's ground. Okay, so the bottom pin goes, or the far right pin, I guess. It goes from a resistor into... Oh, that's interesting. Yeah, it goes from a resistor into 5 volts. And then the top one, same thing. Resistor into... Isn't that what I did? And then they both get... Is that not what I did? Resistor, these are both... Yes, that's 5 volts. There you go, look at that. This is a nice camera. Holy shit. And then this one, same thing, resistor into 5 volts. The pin going in. So why is it like why is it doubling up like that? I mean, it's possible that this encoder is just like different or worse. Like, look, I'm spinning it. I'm gonna spin it like halfway. It triggers once, and then when I finish the spin, it triggers twice. But that's not what's supposed to happen. At least I don't think. I'm using this encoder library, which might not be good. Like when this calls read, what is actually happening? I'm not using any interrupts. If interrupts in use is less than 2, if interrupts in use... What is actually happening here? Oh, return encoder dot position. What the fuck? What is happening? Does the breaker, does the breadboard work? I think the breadboard works. That's possible. Maybe. I mean, I can do it. I can fix this by just like counting to 4 instead of. I mean, I have to assume the breadboard is working. Right? I mean, I guess I shouldn't assume things. But what happens if these resistors don't exist? I'm pulling up. I'm just curious. Does it still like... Do the resistors even do anything? Whoa. What is happening with my butt? Okay, maybe the resistors do stuff. I thought I had the buds working. That's... Oh, this needed to be... Oh, whoops. Yeah, I think the resistors do things because me messing with them is causing things to happen. I hate this kind of stuff though because I don't actually understand it, so I'm just following random tutorials and hoping they work. Like what I want to do is like code things. I don't want to freaking mess with the resistors. It's really annoying. Okay, well now my switch doesn't work. When I release, it's like freaking out. It must be debouncing, or it must be bouncing, and it's triggering twice. What the frick? Oh my god. Maybe I should just use the frickin' these encoders. And it's also possible that like it would work better if I was on a PCB instead of a breadboard. That is definitely possible. That was a similar issue when we were trying to get the NRFs working yesterday. Was that yesterday? Yeah. The NRF only worked once I soldered a capacitor directly to it. This could be a similar thing. I just don't understand how... Oh. Okay, I do actually understand. I mean, look, I could fix this if I just added a cooldown, which is fine. I'm not, like, opposed to that. I did a similar thing with the spinning. So time since released. Yep, I mean, let's just add a 100 millisecond cooldown to this as well. Really quick. Let's see. Time since released. Yeah, I think we just... I hate nesting so many if statements, but... Well, I guess it's just one if statement. If time since released... what is it? Minus milliseconds, but let's just see. Yeah, okay. If milliseconds minus time since released, yeah. Is greater than 100, and this is so messy. Oh my god. I mean, I want to make this number up here like a variable. What is this number? It's like the cooldown, right? Debounce. All right, so if this is greater than debounce time, that means we're allowed to press. Okay, and then same thing here. But we have to then set. Oh, wait a second. Wait. Not same thing here. Sorry. My bad. So the cooldown should be between pressing and releasing. I don't care about releasing. So pressing, that's where the cooldown is set. And then time since released is set here. I forgot what I was doing. Equals. All right. So when we press, we're only allowed to press if we haven't released in the last 100 milliseconds. Let's try it. This is called software debouncing. Oh my gosh, it actually worked. Who would have thought? Okay, that makes sense to me. That's good, I guess. Let's see. Now, what the heck is going on with spinning? Like, holy crap. Why is it triggering twice? I'm literally making sure it doesn't. The thing is, it's triggering, so it's triggering once. It's like two, it's each time you spin it, it's a click, right? But if I spin it and then don't click it, it triggers once, and then the click triggers again. What does that mean? What does that mean? I don't think this library uses debounce. In fact, I'm almost positive it doesn't. And the breakout board encoder, it did trigger double. So I made it count to 2 before triggering a spin left or spin right. It counts up to 2. But now it's triggering twice with the counting to 2. So that means it's triggering 4 times, which is like super weird to me. Interrupts don't use more pins than regular digital pin reads. Interrupts don't use more pins. Rotary encoders do not count in binary. These. Right, okay. Right. The Arduino only reads 1 pin at a time. Okay. I guess that doesn't make sense. I just don't know why the breakout board one worked and this one doesn't when the wiring is like exactly the same. Also, I can't use interrupt pins as far as I'm aware because this encoder is going to go through a shift register. Okay, yes, thank you so much. How are you? Oh, Twitch chat can link things. You can't link things on YouTube. That's funny. Okay, this is pretty sure this is exactly what I have. Thank you, I appreciate it. How far am I scrolling here? Okay. You said there was an example circuit? Did I miss it? Oh. Okay. I tried to do this. The resistor is just going into 5 volts for A and B. C is going into the ground. Right? I did do that, right? Okay. But just keep in mind, I'm not using interrupts at all, so... What? This has 4 resistors? I don't know how delayed you are. I thought I was looking at it. Oh, these guys are using 5Ks. Maybe... I don't think that matters. So, maybe after 1 changes, I need to not... Oh, God. Oh. Oh, sorry. This did not look like a circuit. Okay, thanks. All right. We got our encoder. Oh, God. Okay, we have 2 capacitors. Okay. All right. I mean, look, I'm only having 1 of these encoders, so I'm fine with adding all this. Wow. All right. So we have a resistor going into pin A and a capacitor grabbing from that into ground. And then from the same place, why is this labeled terminal A as well? Okay. And then we have another resistor going into, okay. So that's interesting. I can try this. I'd really just rather do this in code, but if this helps, yeah. Well, hey, well, it's worth a try. Whatever. I already forgot what the 0.01. Okay, I don't have 0.01 UF capacitors. 0.01? I have 0.1. I have 1. 0.01? Isn't that like the mini ones? Oh, that's gonna be like... Shit. I don't have NF. The one's marked with 103. Thank you. I was just going to ask that. I have 104. Jesus Christ. 101. I don't have very many capacitors. I try to avoid... I have a bunch of 104s. Will that work? I like actually hate this. 22. I have a... Yeah, this is the 101. 104 is fine. Okay. If you say so. If it doesn't work, it's your fault. Alright, let's see here. If you say so. What does this do? Oh. Isn't that the same as just doing this? Whatever. Alright. So we still need the resistors going from here to 5. That's fine. But instead of the jumpers going directly into the pin, let's maybe unplug this. What do we want to actually happen? So from... Oh no, we did want that. Oh. Wait. What? Okay, I'm confused. What is this resistor doing? It's going from here to where? What is this? Is it connecting to itself? I don't understand. Like, this one makes sense. We're going from the pin to 5 volts. What is this one going to? Just nothing? Into the capacitor into ground? Is this going to ground? Use my time constant formula to determine the resistor cap value combo you need for 1 millisecond. Dude, I don't even know. I don't even have any frickin' capacitors. Like, I have 104s and 101s and 22s. I feel like I can just do this in code. But I need a confirmation. What is happening here? Like, why don't I just do this where like T bounce is 2, so T is 2 milliseconds. Why don't I just add a 2 millisecond delay here somehow? The resistor is charging the capacitor at a time constant. This is so over my head. It's like, I understand capacitors hold charge and then release it. They're like little batteries. But as to why this helps, I have literally no idea. Is this capacitor just like connected to itself? Is this just connected to the... Is this resistor, rather? I misspoke. Is this resistor just connected to the capacitor? Is that the whole point of this? So... What? So we do need these. I don't know if you can see this. Yeah, you can. Okay, somehow I managed to tangle that. That's awesome. So we do need these, and then we also want another resistor, another 2 resistors. Charging up a capacitor that goes into ground. Okay. Let's just put it over here, I guess. I'm going to shove it into the same hole. Hopefully that's fine. And then this capacitor, Oh, Jesus. Does this have a plus and a minus? I'm pretty sure it does. Well, which side is plus and which side is minus? For the capacitor. The cat goes between the pin of the Arduino and ground. Oh, it goes... Oh, okay. Then what is the... Then what is the second... What does this resistor do? Oh. Like, it's going from terminal A to terminal A. What does that even mean? This is... Oh, it's bipolar. Oh. Okay, so these don't have... Okay, that's good, I guess. So am I doing this right? Like, I have a resistor here. But it's saying it goes between it. So I don't think I'm doing this right. Is this like I'm so freaking... This doesn't make any sense. Why wouldn't they just put the resistor here? If this is terminal A, what does this even mean? How is terminal A going into terminal A? What does that even mean? Oh my God. This is the same shit. What is terminal A if this isn't terminal A? This is no debounce required. I mean, that would be nice. Where's the circuit with debounce required? Oh. Is this literally it? Oh, and then, okay. So if you do the hardware debouncing, you just, what do? You just read it? What the frick? C++ is hard to read. The code reads a current state of the rotary encoder, values pin A and B, and appends it to the previous state. Oh. Oh. Interesting. Okay, that is good. Okay, no. I like this. This needs the interrupt pin though. I can't use the interrupt pin because, again, I'm going through the shift register, so... The switch is inside the dotted line is in the rotary encoder. The parts outside of the dotted line is the added parts. Right, I understand. That's not why I'm confused. Oh, wait. Okay, no, yeah, I'm not confused about that. I'm confused on how this is terminal A and this is terminal A. That's what I don't understand. And I assume this is terminal B. Like, this is terminal C, this is the ground. These are the two switches. I get that this is on the inside. I just don't understand where this resistor is. Like, what is this? What the frick? Oh, this guy's using 104. Wait, that's, yeah, okay. This guy's using 103. Don't want to. Okay, if you don't want to implement the more sophisticated approach from the Burns paper, you can just add a couple of capacitors from the signal pins to the what is the common pin? So I assume these are the two pins of the rotary encoder, 4 and 2. This is counterclockwise, this is clockwise. But I don't want to, I mean, do I want to, and this is the interrupt once. ISR for rotary encoder. What is ISR? I'm not sure. Like, how do I do this without interrupting? Okay, V plus resistor, rotary A, capacitor. Okay, so I only, okay, I can try that. That's what this looks like. Okay, I can actually try that. Let's try that. So you only need 2 resistors. That makes more sense. So we also want, this is gonna get a little crazy. Oh god, hold on. This is going to ground. I don't know if you guys can see this. Okay, now you can see it. This is ground, that's good. These are all good. Okay, the resistors are good. So now 2 capacitors. How close should these capacitors be, by the way? Like, I feel like, okay, I have a feeling everything should shift over. And then the capacitors are as close as possible to the rotary encoder. I sure do love breadboarding. Yes, I do. Oh my god. Okay. So these are 104 resistors. One there. And you said they go both ways for some reason. I don't know why. I said resistors. I meant capacitors. I don't know why some capacitors go both ways and others don't, but whatever. All right. I mean, you can see what I did. Yeah, I mean, the far left and the far right go to the Arduino, right? All right, this looks good. Interrupt subroutine. Hey, Pixel, what's up? Oh God, it's like dreams, but real life. All right, so we've wired up some capacitors. Let's see what happens. I'm sure it'll work just great. This is not the right code. Well, we should probably plug it in. Does the code need to change or what? I don't think so. Okay, so I mean the switch still works. That's good. I'm kind of scared to spin this, but okay, it still is doubled. Whatever. I don't know. The switch wasn't the issue though. it's the spinning. Electrolytic capacitors are polarized, right? Okay. Interesting. I'm just curious, like, what's actually happening? Like, okay, what if what is happening here? I make an encoder. You have pin 1, pin 2. They're both set to pull up. Okay, like right off the bat. I'm not sure if I can do that. I mean, that's fine. Okay, that's fine. Oh, and you're writing them to high. I don't really understand this. Didn't they say there was like a bounce library or something? Bounce 2. This is what I'm using right now. Man, part of me really wants to just do this in software, but I feel like I should figure out what the hell's going on. Charge time equals resistor times capacitor. Okay, well, what's the value of the 104 capacitor? That's interesting. A charge rate timed. So, what is my current setup doing? I guess is my question. I'm just checking the wiring right now. It looks correct. As long as your program continues to call read quickly enough, you'll get accurate results. Low resolution. Okay, let's try something. All right, we're gonna try something. I'm just going to do this from scratch and see what happens. So can I get rid of this? Thank you. We have our rotary encoder thing. We have this encoder thing. I'm just gonna delete it, okay? And new position equal. No, we're not gonna have that either. We're just, you know what? Let's not delete it yet. Let's. Shit. I don't know if I want to delete this. Let's just do encoder pin 1, encoder pin 2, and then what's going to be 4 and 5. We're going to comment this out. We're going to comment this out. I mean, maybe we can write code to generate new position some other way. For now, though, let's just return. Nothing. Let's return the state value of nothing. Okay. All right. So this code is not going to be used right now. In fact, we're just going to do that. So right off the bat, let's just set these pins to input pull up. Okay. And I just want to read the pins and see what happens. I mean, this is probably not a good idea, but let's print this and print this and then return. Okay. And I am going to, I mean, I want to just unplug all of this. I'm going to be honest. Like, I don't even know, because, like, I can't get it to work. So we're just going to, we're not going to use any of this right now. We're just going to keep the 3 pins, 1 ground, and then the 2 for the switches. Okay. Making sense so far. We've set them to pull up. That's fine. So, like, what's actually happening here? Let's find out. So I'm going to upload the code. Okay, it doesn't like that. Yup, encoder.read definitely gets an error. That's fine. Okay, it's fine. I mean, I didn't terminate it because I actually wanted it to go to the end, but fair enough. All right. So let's see what happens, I guess. Didn't. Oh, no. Okay, this does make sense. I swear this makes sense. Do we get some zeros? Uh-oh. Okay. Well, we might be getting zeros. I just... Oh, we are getting zeros. It's working. Ah, okay. Okay, this is fine. It needs to be a new line. Oh, no. Okay. Okay. Oh my god. Okay, this is great. Yay. So we're getting stuff. Sure. So how about if this equals 0 or if the other one equals 0. Then print, because right now just printing 1 1 over and over and over is not helpful. Time constant calculator. Why do I want that? I don't really care about the hardware debouncing, to be completely honest, because I have no idea what's going on. All right, this is interesting. So maybe, wait. Uh-oh. Oh, that was weird. My little cap thing is preventing me from clicking in. All right, well, we just won't use that. Okay, now I'm a little confused. Oh, I'm not printing. Wait, why isn't the switch? Oh, yeah, that makes sense. Okay. It doesn't print it unless that's true. Fair enough. I just wanted to like print the switch thing, but here. Okay, it's freaking out. So maybe we do. Why is it printing so much? Oh, there. Touching the. Maybe there's a loose wire. I don't know, but okay, fair enough. So if I spin it once, one click to the left. Oh my gosh! All right, one click to the right. Let's do that. That's what we get. Okay, one. This is interesting. So one click to the right. And this is what we got. So what does this mean? 0, 1. I believe 0, 1 means that... well, I can just say. So switch... Is this... First off, is this even wired up correctly? Far left is 6. Or 5 and far right is 4. Shouldn't this be reversed? Or I mean, I guess it literally doesn't matter since it's 2 switches. Okay, whatever. So switch 1 is 0 and switch 2 is 1 for a long time. And at some point, they're both 0. And then they become 1 0 1 0 and then a bunch of 1 1s. So the 1 means what? That means the switch is closed or open, doesn't it? Because once you close the switch, it goes to ground. Which makes it a 0. So the first one is closed and the second one is open, and then they're both closed. So this is the debounce issue right here. Like if I spin this, we're always getting Or wait. Oh, this is hard to read. Okay. What if I only cared about if the previous was different? So like so like 0, 1, if this was different than the previous thing, I think that's a good place to start. Previous spin. I'm not using that anymore. Let's see. I mean, I can just, there's an easy C++ way to do this. I know there is. I can make like a little array. Yeah, let's do that. So, it's int encoder previous state. I feel like I have a variable. Okay. Should be 1, 1. Okay. Did I do this right, or does this need to be here? I don't remember. We're just gonna try this and see what happens. Well, actually, this should. Okay. How do you make an int array? Right, the diagram of pulse. Yeah, no, I remember what it looks like. The encoder can never go from 0, 0 to 1, 1 in one step. Right, yes. Oh, that's true. Okay, wait. So, that's a good point. So what does that mean? I just want the before 0, 0 and the after 0, 0 and to see what that is? Is that... And then this is the debounce though, right? Like, well, wait. Before 0, 0. How does... Oh... Oh, I'm confused. Oh man, this is hard. Oh, this is nice. Okay. So what is 0, 0 here? 0 is connect. 0 is when the switch is connected. I guess it doesn't matter either way. So I guess 0, 0, 0 is this. Sure. So 0, 0. And then you're spinning clockwise. So it starts with 1, 0. And then at some point... Whoa. Yeah, 1, 0, and then at some point it's 1, 1. And then it snaps. Oh no. And then it's 0, 1. Oh my god, what the frick? Okay, there has to be an easier way to do this without me having to write this from scratch. There has to be an easier way. Arduino. There has to be an easier way. Basically count 0, 1 and 1, 0, but ignore 0, 0 and 1, 1. Should I... Okay, should I do this from scratch? need it to be versatile. I just want it to work. Oh, I see. Yeah, long press, double. That's kind of cool. Okay, we can do this. We can do this. Okay, I just spun it to the right. Wow. So it's in 0-1 for a really, it's in 0-1 for like a really long time. This is the wrong web page, I'm sorry. Okay, it's in 0-1 for a really long time. What is 0-1? This is 0-1. So I might have the pins reversed. It doesn't matter though. It's in 0-1 for like a really long time. And then oh, and then it goes to 0-0? Hold on, I definitely have the pins reversed then. Because this should be 1-1. Okay, let me try, let's just see what happens when I reverse the pins. Or can't I just reverse it in code? I want to reverse it in real life. What do the resistors even do here? I mean, I guess I could add the resistors in and see if anything changes. What the frick? Oh. Oh, we were trying to figure out how the hell to make an int array. I really do not. I shouldn't have to freaking search this. Why is it so hard to make an array? I just want the syntax. Oh, it is after. Okay. Oh, and I have to specify the size of it. Right. Right. All right. All right. Seriously. Can I not initialize it? Maybe I can't initialize it. Jesus. All right. Sorry. Holy crap. All right. So I switched the pins. And I rotated it to the right one time. So it's 1-0. Oh, and then where's the 1-1? Okay, hold on. Oh, this is really confusing now. So I spun it to the right, and it was never... Wait, is it ever going to be 0-1? Maybe this is correct. So in this, it was 1-0 and then 0-0 and then nothing. So it was 1-0. It was 1-0, then 0-0. Shouldn't it have been 0-1 at one point? Where does this, the two pins, like where do they snap? Don't they snap like here, for example? So they snap, okay. Let's... Okay, I see. So it's, yeah, 1-1. So it starts at 1-1. It's 1-0 for a lot. 0-0. I never had the 0-1, but then it should snap back to 1-1, right? Am I understanding this correctly? Let's do it in Python. Just list the states in the order. Yeah, that might help. Arduino output left and right when it sees 0-1 and 1-0, and output nothing. Are you sure? Wait, is it really that easy? Right, I understand that. Is it really as easy as just like 1-0 is to the right, 0-1 is to the left? Is there actually like no thinking and it's just like... Wait, is it actually that easy? Are you sure? Yeah, no, that is... Wow, okay. I think that's right. Okay. Okay. Why is this color? Did we... I still don't... How do I initialize an array? Why is my array this color? All right, whatever. There are 4 possible states. No, I know you can like be in between. No, yeah. Okay, I understand. Yes, I understand the 4 states. So you think I should... I think we should keep track of those states? Zero, 1, 1, yeah. I'm gonna try. Well, oh my god, I really don't want to do this. So, okay, write them down in the order that happens. What do you mean by that? Like, what would that even do? Do you mean like literally write them down like in real life? I mean, they're right here, right? So it's like if you're turning like clockwise, for example, it's snapped here. It's gonna be 0, 1. 0, 0, 1, 0. Is that? And it's gonna snap back to here. Wait. Bodger, what do you mean by... So 1, 0 is to the right, 0, 1 is to the left? All right, hold on. I'm gonna actually do something. So I'm gonna use this array to just get current value, or I don't think this array is even helping me, to be honest. It's not making anything simpler. I'm not even gonna use this. I mean, I have the 2 values right here. So if we get 0, 0, or we get 1, 1, it doesn't do anything. So, okay, if we get 0, 1... Well, wait, why don't I just do that? Hold on, I'm overcomplicating this. Why don't I just do this? If we get 0... Okay, if we get 0, 1, what does that mean? So you think... I'm just going to do this. So basically left or right. But like this, obviously, every time I turn it, both happen, which is fine. That's where the debouncing comes in. The trick is to know, like, okay, I just want to see. Okay, I just turned it to the left and I'm not getting 1, 0. Did I? Oh, Jesus Christ. Alright. Yeah, that's probably why I'm not getting 1, 0. Okay, I turned it once to the right. I get a bunch of 1, 0s and a couple 0, 1s at the end. That's fine. And then I turn it to the left. I get a bunch of 0, 1s. And then a couple 1, 0s at the end. So this is the stuff I need. This is the bounce, right? That has to be the bounce. I just spun it once right and then once left. I mean, why not? Why don't I just read this first value? I want you to be able to like. Alright. If 0, 1 happens after 1, 1, it's going left. I think it's simpler than that, though. You know, you're not wrong, but 0, 1 happens before 1, 1, it's going right. I think Bondrew is like even more right. Well, not even more, but like is also right, and it's simpler. Like it's literally just like if I spin it right, it starts with a 1, 0. And if I spin it left, it starts with a 0, 1. Isn't it like literally that simple? So now the trick is like, okay, I'm going to spin it left twice. That was once. That was twice. It's a bunch of 0, 1s followed by some 1, 0s, and then a bunch of 0, 1s followed by some 1, 0s. Now I'm going to try to spin it twice fast and see what happens. Okay, I think I just spun it twice fast. I'm gonna make this easier to read. Give me a second. So basically, if the previous spin was this, and if it changes, I want to just draw a line. I mean, can I just... There's so many ways. I'm just trying to think of like the best way. It doesn't matter. Okay. If the previous pin 1 wait. Does not... Yeah, I just want to see if they swap. Wait. Hold on. This isn't right. You know, let's just make it even simpler. Can we try comparing strings? Is this are strings even in this? Do I even have strings? Is this even a thing? Hold on, I actually don't. Dude, this is such. I hate C++. Strings aren't even a thing. Okay, hold on. Maybe I need a capital S. All right, maybe they're a thing. All right, strings are a thing. If previous state equals 1, 0. Okay, this is like the most complicated code just to, Jesus. Does this work? I don't think this string comparing is actually gonna work, but we'll see. Maybe it will. I hope it does. We'll see. I literally just want to print a line. Oh, wow. Okay, it almost worked. Okay, it actually did work. Okay. All right, it actually did work. It's just the wrong order. I still hate C++, but that's neither here nor there. Okay, now I can actually read this. So I'm just gonna spin it right like a bunch and see what happens. So this is just me spinning it right a ton. I'm getting a bunch of 1 zeros and then a 0 1, a bunch of 1 zeros, and then a 0 1. Do I always get a 0 1 after? Like, no matter what? Is it... Wait, is that the bounce or is that supposed to happen? Why... I have to know what state it was before it changed to know if you're going right or left? Wait, why? Like, what do you mean? Oh, so this time I held it in between. Oh, so I guess you're saying like this. Okay, I see what you're saying. Yeah, I think you're right. Yeah, because like I don't like what the frick's happening here. I don't know whether this is left or right. That's a good point. Okay. We're gonna write some really, really awesome code right here. Are you guys ready? Yes, Swaggin, exactly. Exactly. Beep, beep, boop, boop, I am a robot. Okay. Oh, I don't like this. Okay, can I not? I don't want to print the 1-1s. The 1-1s are not good. If previous state does not equal 1-1. Print the line. Print 1-1. And print 1-1. Okay, okay, here we go. Now we're only printing 1-1 once. There we go. There it is. Here we go. What's up, Snavalier? Long time no see. How's it going? Oh, you said that too. Nice. I'm doing so well right now. You have no idea. I'm thriving. This is my element. Coding rotary encoders. All right. Okay. Unironically though, this I think we figured it out. Maybe something like that. I spin it to the right. It's a bunch of 1 zeros, then a 0 0, then a 0 1, and then a shitload of 1-1s, but we're only printing one of them. We spin it to the right again. A bunch of 1 zeros, and then a 0 0, then a 0 1, then a 1 1. Okay. Let's spin it to the left. 0 1s, 0 0. Okay, this time we didn't get a 1 0. So it looks like this. Well, wait. You said we couldn't get a 0 0 then a 0 1 1, but I think it's because the Arduino is just really slow. I think that's the case, which is fine. And then if we like hold it in between, that's what happens. It just stays, which is making sense. How are you doing, dude? What's up? Rotary encoder is a thing. I know, but like... I want to be able to code the bounce properly. Should I just... This is the board manager. Like, I was using this, but it was being really weird, and I was hoping I'd be able to do it better myself, but I don't know. Oh, yeah. Yeah, I got the MP for Cluster Factory. That was fantastic. Totally second that game again. Oh, you were playing Cluster Factory again? Is there a rotary encoder library that I'm able to like add bounce into? The encoder can never go from 0 0 to 1 1. Right. But and the reason it appeared to here is because it just wasn't printing fast enough. You know? Okay, I think we do just use this library and then... Oh, man. But like, okay, hold on. I still need to get this working through a shift register. And I think that's going to be really difficult. But I don't know. Oh, here's this guy's thing. The versatile one. Oh my god, can you actually set? Oh, there's set short press duration. Should I just use the breakout board thing? I mean, but no, I don't. Wait. Whoa. Okay. What's this looking like? It's interrupt driven though. I don't have access to, I'm not able to use the interrupt pins because I don't have enough pins. I'm using the shift, I need to use this through the shift register. I do like this though. Does it have to be interrupts? Oh, this is interesting. Highest count. Man, I mean, okay. Right, interrupts have something on chain. Yeah. All right, I want to try this. We're just gonna use this. Okay, we're just gonna use the encoder thing. The encoder library, and I'm gonna figure it out from there. Hold on. Time. I don't want to. Sorry, I don't want to delete the wrong code. All right, there we go. This is what we're gonna do. This is what we're gonna do. So this almost works, but it doesn't. I'm going to get rid of the counting for now. If spin. So all the spin count code is just completely eliminated. So now I want to see like what's like the raw output of this. Oh, sure. Okay. So obviously I did something wrong. I definitely did something wrong. Hold on. What does it keep saying? Spin right? Spun right? Whatever. I mean, it could be either of these. If true. That's not good. Hold on. I didn't think about this. Hold on. You know what? We're going to do this instead. We're just going to do 1. Okay, we're going to do great. I didn't really consider The ramifications of what that change meant. All right. Right. So, okay. Each spin is 4 spins. Okay. So, like, can I just set this equal to 4 and then move on from this torture? I feel like I can't, though, because once the code slows down, or like once I add more to the loop, it won't be this many spins. Although maybe it will be. I don't know. It all depends on how... Oh, look, it's working now. Okay, but like I feel like this isn't gonna work once I do more stuff. The only reason this is working is because I'm calling this loop so fast. At least I think. This does not feel like a good way to do this. Yeah, sure, Wagon. Yeah, please. See you later, Bonju. Have a good night, dude. Oh, you never played Wait, then what? Totally sucked into that game. Do you mean Dreams? Oh, you're okay. The game Dreams. Got you. You can't find your Rotary example. Everything depends on how often you do the polling. Right. So, okay. Is 100 milliseconds 1/10 of a second? Okay, I don't understand. I don't understand how this is happening. Here's what I mean. If spin left count is greater than or equal to 1, sure. Let's just set it to 1, okay? This is what I mean. Let's set it to 1. If milliseconds minus time since spun is greater than debounce time. Okay, let's just set the debounce time to 1,000. And remember, what happens? How am I still getting... Okay, hold on. Something's wrong with this code. It should not be able to print 4 things that quickly. I just need to see which print statements are which, so I'm just gonna label these. This is real coding right here. I don't know how to get the debug statements working, or the breakpoints working. I tried and didn't work, so. Okay. How are 4 of these printing? Oh, okay. Okay, I mean, let's just add this. I didn't want... Why didn't I add this? If previous spin was 1... Isn't spinning... What is spinning left and right? 1 is right, 2 is left. So if the previous spin... Oh, I see. Okay, I don't even care. I don't care. We're still gonna add the timer. I don't care. We're just gonna add the timer every single time. I just want to see if this does what I think it'll do. I just want to spin it. It's a 1 second timer as far as I understand. Okay, and then the other, and then it like comes in 1 second later. That's so interesting. What? I'm resetting this. Oh my God. Wait. So this runs, it resets the spin count, okay, and then it loops back around. New position, it's reading this. I don't want this to read. If I just spun, I don't want it to read until the cooldown is done. Okay, hold on. Right? I mean, I could be completely off on this, but let's see. Easier to do that. And yeah, I'll check out the tutorial, just hold on. I'm not going to add the cooldown yet. I just want to see what happens when I do this. This is literally just like... It's printing spun right or spun left, depending on what this senses. What the library is. Yeah, so now we're back to... printing 4 at a time. Although, what the hell happened here? Right, 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 left, right. Yeah, see, that's... interesting. This sucks. Yeah, that's what I thought. 100 milliseconds is, yeah. The delays are shifting the window of when the next read happened. Right, yes. No, that's not true, but that's what I want to happen. You're sucked into dreams again? Nice. My tutorials are paying off. That's funny. Yeah, Snavalier, I've been doing robotic stuff. If you want to check out my YouTube channel, Acer Robotics, you'll see it. If A does not equal last A and A does not equal B, Is this, am I reading the pins again, like individually? If A does not, if pin A does not equal the previous pin A. Okay, that's interesting. We don't need, but let's, should I check out the tutorial you posted? Okay, he is using the breakout, but should I just add the resistors in? I mean, okay, okay, hold on. Let's add the resistors in and see if we get the same shit, because so the resistors are basically the pins going to the power. Which is identical to what the breakout board does, as far as I understand. I'm just making sure they're like properly in. Okay. Oh, yeah, that's right. So the resistors are back in. So it's identical to what the breakout board is. At least it should be. I will watch more of that video. I just want to see if we get the same stuff. Yeah, okay, it's exactly the same as far as I can tell. Freaking 4 at a time for some reason. I understand how it works now. Am I building Skynet? I'm building a hexapod. It is fun, yeah. Wait, Snavalier, have you checked out the? Did you check out the YouTube channel? I don't have any clue what you do. I'm building a hexapod. But yeah, hey, I'm glad to hear it, man. He makes the circuit I posted above. It has a debounce blocking function that prevents multiple counts. He makes the circuit. Do you mean the code? So debounce blocking. Okay, yeah. Let's see. Yeah, nice, awesome. It's looking good. I'm not able to use that. I would love to. Maybe I should. Should I? Okay. Should I change my entire thing so that I'm able to use the interrupt pin? Because right now, the shift register is using it. I don't have enough pins to do everything I want to do. I mean, I could, okay. Assuming the interrupt pin is D2. Oh, God. This would be so... I mean, it would be so much easier if I just used the interrupt pin. Wait, how many... Like, I could get rid of the potentiometers. I could have one of the shift register pins. I could get rid of one of the potentiometers, have one of... No, that wouldn't work. I don't know. I don't know. Maybe I just don't use the rotary encoder. I really want to have one on here, though. It would make things a lot nicer. Right. Okay, I could do an interrupt, and then that interrupt could read the shift register. Could I... How does the shift register know if an input changes? Like, what if... What if the shift register used the interrupt to just check if any of the input has changed? Can I do that? And then it reads it. Okay, I can get 16 extra free pins using a PCF 8575 connected to I2C. I thought I was already using I2C for something, but maybe not. Or can you do multiple things into I2C? Like, I haven't even begun trying to get the shift register working. 4 months? Oh, you can't do multiple things at the same time? Okay. So, what is... You could get 16 extra free pins. And, I mean... Whoa. So this thing hooks into your IC2, oh my god, I2C pins. What are they called? Jesus, I2C pins, and gives you access to all these, yeah. And how is this different from a shift register? Okay. So 16. I mean, can I... What can I use these pins for? Like... Because, like, I need all the analog pins for analog things. I need the 3 SPI pins for the SPI things. I mean, I guess this reset pin could go in the shift register, for example, or whatever. Oh, man. It's digital only, but it's bi-directional. Okay, that's cool. If I could make use of the interrupt pin, this would be a lot easier. Do I need 2 interrupt pins, or would one work? Where'd that video go? This one? Yeah. Oh my god, can you guys not hear the video? Why didn't anyone say anything? Wait, wow, okay. Is the Discord... Yeah, the Acer Gaming Discord's still open if you want to ask Dream stuff, of course. Shit, guys, sorry. You're supposed to be able to hear the video. Holy shit. God, like, I'm watching this fucking video and...
Input pull up because it won't go down to 0.
And you guys can't hear it, like...
But that's the switch. You don't have to use the switch, but I will to set the correct temperature. So having turned...
The AW... Okay. What is that? What on earth? I have no idea what I'm looking at. Okay, so... Yeah, no, now you can hear it, yeah.
Turned the knob to 22, say, I'll then press it and go, that's it. And the code will then say, oh, you want me to go up to 22 degrees. Great. Here is where we tell the Arduino, or ESP32, which pin it is that you're attaching pin A and pin B to.
It's a G, yeah, okay, it's an IO expansion, right. Okay.
So I've got pin A here, which is pin 32, and pin B, which is pin 4. These are arbitrary choices for me. Yeah, it can be any of the pins on the ESP32.
On the ESP32.
On the Arduino, can only be pin 2 and 3.
2 and 3, right. Okay.
And I've said, do it on a change, because we need to detect all stages, whether it's gone low, gone high, on each of the pins, right? So it's not just falling or rising, there's been a...
Look, I mean, we can set it up right now to use interrupts, but that means pin 2 and 3. Thank you, Carlos. I appreciate it. Okay, but that means pin 2 and 3 I won't be able to use for the shift register. So, okay. But let's think about this. The TFT reset, that can that be the shifter? Do I even need that? I don't even know. I don't know how, oh God. And like touchscreen, like the C, I don't know if any of this can be passed through the shift register or not. I mean, especially like the NRF shit. So that leaves, I mean, okay, that leaves like, maybe I can just get rid of the potentiometers and then use the shift register in D4, A2, and A7. That way I have the 2 interrupts for the encoder. Yeah, well, the thing, so Ravi, it's tough because like I'm not stuck on it per se, but I'm scared that it's not gonna work. Right now, when I spin the encoder, okay, my encoder library counts it 4 times. And I'm not entirely sure why. And it's really annoying. Why? Wow, okay. It seems like I dropped 15,000 frames earlier, so if you refresh Twitch and or YouTube, you'll be back into the present. But hey, Zodiac, what's up? Oh, yeah. I am aware pots are analog, but I'd be able to use the analog pins. I'd just get rid of the potentiometers and just use the pins. Did you take a look at ESP now protocol? I mean, I checked it out a little bit, but I don't want to use the ESP if I don't have to. So, right, but like a simple fix for this would be to just basically divide this by 4, which I have. I'm able to do that with my spin count, right? So now when I spin it once, it counts once, and this is great. My worry, though, is that this isn't going to work. Like, once I start getting more code, this is just not going to work. So, I mean, I think the only way for this to consistently work is to use the interrupts, but I mean, it works for now. Worst case, I just don't use the rotary encoder. It just feels really weird to count it 4 times. Wait, hold on. What's actually happening here? New position equals. So this is getting read like constantly, right? Position does not equal. What is serial? What is actually the position? Maybe we should try to figure that out. What is it? What is it? So one spin is changing the position 4 times. But sometimes more. They're analog. Analog? They're the switch encoders. Okay, you want me to keep watching the video? Are you making some sort of game or some sort of I'm making a remote, I mean, it's in the title, just saying, but I'm making a remote control for my hexapod. I already have one, and I'm remaking it using a PCB. And right now, I'm in the process of just like making sure the wiring on my PCB is correct, right? All right, we can watch the end of the video.
Change on all of them, and they both run the same routine that we just saw. So the loop just says, if there was a movement, go and print out what it is, or go and find out first of all by checking it, was there one? And if it's not 0, which means it was a rubbish, it was a switch bounce basically, that don't do anything, but if it wasn't a switch bounce, add in the right amount. Oh, and there's the push button, which I don't think I showed you, so let me just bring that back quickly. Right, so if I turn that now, there are the Marco's way of doing it. In some ways you could say, is it a better way of doing it? And I think it must be, because we're not waiting. Yes, okay. But this works very well. So Marco's done a great job, and his paper that explains all this, you can print off and read in the littlest room in the house if you want for many weeks until you understand it, which is basically what happened to me. But in between the house move and the rest of it, I couldn't really give it my full attention. But well done, Marco. That's really interesting, actually, and definitely a different way of doing it. In some ways, you could say, is it a better way of doing it? And I think it must be, because we're not waiting for 5 milliseconds, or potentially longer if you've got pause switches, on every single interrupt. Right? So we don't interrupt and then go, I'm not accepting any more interrupts for 5 milliseconds. Even if there were no bounces and it was a proper interrupt, no, not accepting it, because it can't possibly be right. He's saying, I'll accept everything.
Sure. Yeah, send it.
But through the logic of his code, he can determine whether or not it's a valid transition of these switches from one state to another, the combination of the two, and says, yeah, that works. And I bought 10 of these. Was it 10? No, pack of 5. Look.
I don't understand why when I hooked this up. Okay, so when I hooked this up like this, why does the zoom reset? Oh, whatever. Using this one, it counts it 4 times. But when I use this one, it only counts up twice. So like that makes me think I did something wrong, but as far as I can tell, I haven't set up the exact same way. Maybe I don't though. I mean, this one just has 2 10K resistors, and that's I do as well. I mean, I could try flipping the pins, but then like, okay, let's just try this. I'm gonna use my same wiring, all right? Oh, what the frick? Okay, that doesn't matter. Use the same wiring, but remove the resistors, and then just wire this one into my existing wiring and see if the same stuff happens. So ground. Yep, that is ground, and it's the exact same. Exact same. We've got the plus, which is hooked up to the resistors. This is just hooked up to the resistors, yeah. So, alright. That's where the resistors were going. That makes sense. We've got the switch button. Which was this. And then we've got the two pins. I don't know which one is DT and which one is CK, so we'll try. I mean, it's easy enough to switch. So, like, this is what I had, but with this thing. So, I don't know. Let's see what happens now. It's freaking annoying. Oh, wait. Oh my god. Wait, do you think it's the wait, so it's the encoder? Oh shit. So I am fine. Check the power bus. Some breadboards. Do you think it's the breadboard? Wait, so okay. If what you're saying is true and the encoders are literally just different, that makes so much more sense as to like why I'm getting the results I'm getting. Oh. It's counting up by 2. Right, so, okay. So let's hook this back up. And now I'm spinning it once and it's 4. So, okay. They have different resolution, but the same number of indents. So what does that mean? What do you mean by resolution? Is that a good thing? Like, or did I buy nice encoders or bad encoders? I guess is my question. Like, what is an encoder? Is the number of pulses output by the encoder during 1 unit of movement. It determines how accurately the encoder can provide feedback to the controller and affect system performance. Okay. Is a high resolution... That feels bad, though, because the more code I add to this program, the less reads I'm going to get. Will that be okay? Yeah. Pulses per rotation. And a pulse is like how many waves there are. I might have just deleted it, but oh, this thing. So right. No, I understand that. The click is the The click is the indents. I mean, should I just... Okay, let's just keep going, I guess. Let's just keep going. So we did do it right. Wow. All right. Now, can we get it working through a shift register? That's the next question. We have this, which is this. Okay. And I want to try and get this working. So, first, let's just do a button. Let's just do a really simple button. This is not exactly a button, but it's close enough. Well, first, how do I even use this? Pin out? I don't even know. Okay. Oh, right. So, interesting. Well, how else? Don't do it. You'll have too many issues. So is it just not possible? I think it works fine. Yeah. I think I should just not use the rotary encoder, to be completely honest. I really want to have one, though. The timing will have to be very strict. Right. Okay. I still think I should use this. Or rather, I think I can use this. I'm just thinking. Yeah, so if the rotary encoder has to use these two interrupt pins, to actually work properly, I mean, let's just do that, I guess. Well, let's do that. It's gonna use pins 2 and 3. So those are the two interrupt pins, okay? We will work out how to use the shift register later. Should we not use the shift register for any inputs? Oh, man. That ruins my entire plan. So, for example, two bumpers, the rotary encoder switch, and just a dedicated button. Would using the shift register for that be not good? Okay, you can use it for the encoder click. Okay, it's just for the spinning. That makes sense. That makes sense. Okay. So let's keep going then. 2 and 3. So this is using the interrupt pins. Will it be more accurate potentially? I don't even know how to measure how accurate it is, but Well, it's reversed now. I don't know if reversing it matters, but we're gonna swap it just in case. I mean, I assume it's working better. I don't notice any difference, but because it is using the interrupts now. I think. Yeah, look. How does it know? Whatever. Well, that. Okay. So I just can't use 2 and 3 now. So now I have 1 pin for the shift register. I'm thinking. Oh, man. I mean, what do I do? I'm wondering if you can run the NRF through. Yeah, I don't know. Hey, ADB. Thanks, man. I appreciate it. Live came through your feed. Nice. Hey, I'm glad you clicked on it. We are having so much fun right now. trying to figure out how to fit a shift register into all of this. I mean, okay. What if I don't? You said the I2C thing would work. I want. I kind of, well, I guess, what do I want more? Like, I don't want to get rid of any of this stuff. I wish I could get rid of this. Yeah, is that the easiest solution? A second microcontroller? The easiest solution would be to not use a rotary encoder. Okay. It would be to just use like a left and a right, but just buttons. I mean, now that I think about it, I could just use the joysticks. Okay, all of the buttons and bumper switches can be done on the. Okay, no, but the problem is, do I have enough pins to even connect the PCF thing? A 16-channel I2C I/O expander. And is there a through hole? Is there a through hole version? Or should I just, okay, I guess there's just this. Okay. So this is it. Here's this thing. I'm totally fine with using this. How do you hook it up? What the frick is this thing? Is this an Arduino? Okay. Okay. Stop me if this is a waste of my time, but so far this, I mean, it's just a bunch of LEDs, but fair enough. Of course you need pin 2, so that you need the interrupt pin. Jesus Christ. Well, that already does work. Unless can I put the encoder into this? The CS pins can work through PCF. That's interesting. Okay, but could it work? What's the difference between the PCF? Well, oh Jesus, this is annoying. Okay, you know what? New plan. The encoder might. Here's the new plan. No encoder. No back button. We're going to use the joysticks, or just one of the joysticks, to be able to do the values. So like, for example, I wanted you to be able to change your servo offsets, for example, with the controller. So like, to change your value, you would spin the rotary encoder. But you know what? I guess we could just do the joystick. And like, but like, I want the click feeling. How could I make that feel? Yeah, I mean, it'll be very touchy though. Like, to get the exact value you want. And then we don't need a back button either, although we might as well. Because like, I guess if you enter like a specific menu in the controller, the joysticks will no longer control the hexapod. That's okay. That would actually be fine. That would be fine. Okay, we don't need the rotary encoder. It's just causing so many issues. Cause like I want to use the shift register. I want to have access to all these inputs. But the rotary encoder like is so needy. It's like, yeah, I have to have interrupt pins. And if the timing's even a little bit off, I don't know. It doesn't know what the hell's going on. It's the joysticks, just 2 analog ins, super simple. The buttons, I can shove them all through a shift register. God, like the rotary encoder, it feels so nice to use, but I don't know. Like, how would you even use a rotary encoder if you have 2 of them? I guess you don't need the interrupts. But of course, through a shift register, it's gonna have an aneurysm. It connects to I2C and power pins only. Okay, so why did it need the interrupt pin? Or maybe that's interesting. So like this thing, why is this thing connected to 2? Is this just wrong? And then are the 2 analog, are these I2C? Is that A4 and A5, I assume? I mean, they even labeled it interrupt. Okay, so it's optional. Okay. Okay. That's interesting. Okay, so you're saying with this, can I put multiple things in A4 and A5? Because right now it's I think it's the gyro right now. Yeah, and it has to be. But can multiple things be into this? I mean, that would be amazing. Well, is it literally free? And it's using the analog? Okay. Okay, so if we use that instead of the shift register, we would be able to keep our rotary encoder with the interrupt pins. We don't, and then we would just shove it into the A4 and A5 and just get 16 free pins. Multiple. Okay, and I'm curious, how can they differentiate? Like, how is it just some analog magic where, like, how does the Arduino know which device it's talking to? I didn't mean to do that. It's cheap too. Okay. I mean, this is better than the shift register in every way. Oh, it's digital, but it's in the analog pins. Does that? Yeah, fair enough. All right. I don't know what I2C is, so. Oh, it's just a, okay. Why the hell don't I use this? This seems like significantly better. PCF has 4 different I2Cs. Oh. Oh, okay. See, that makes more sense. Okay, so you can have 4. I'm going to have 2, right? Well, I'm already... So, it'll be the gyro, and you set it up in code. That makes perfect sense. And then the thing. Okay, well, let me order them really quick. This seems very nice. I don't want that many. Well, shit. I mean, 10 is... So this is $2 each. This is $3 each. All right. And this is it, right? This is it. So you're saying I can... They're doing something special. Got you. So you're saying I can shove this into the I2C pins, and it just gives me 16 pins. And I guess my final question is, how do I use those pins? So for example, with the NRF chip, hold on. Like this, I'm putting in the number, like the actual pin. How do I do that with a pin that's extended using this board? That's my main issue. Cause if I know how to do that, why, like, I can just, I can put all of this shit in that if I wanted to. Through a library? What do you mean? Like using a library, it can create more pins for me digitally. Well, okay, whatever. Regardless, I definitely do want this, so I'm going to buy it. Free delivery Saturday. Oh, that's in 2 days. That's not bad. Keep in mind that timing critical. Yes, I understand that. I totally understand that. I'm just like, this is good because the shift register used normal pins. This thing uses the freaking I2C pins. So it doesn't like get in the way of this shit. Okay, this is good. I'll be right back. And then we'll update our schematic thing, and then we got the encoder working, I guess. So this is just gonna use these pins. What's the next thing I want to test? We're not using the shift register anymore, so screw that, I guess. I don't know. We can try to get the gyro working. That could be fun. I don't know, but I'll be right back. All right, this is cool. Yeah, I didn't realize, cause like I didn't realize the I2C pins could be shared. So this is really good. So those pins could be shared, and the SPI pins can be shared. Is that correct? This is huge. All right, this makes me happy because this. Man, like I searched ways. Oh my god, I searched ways to extend pins on the Nano and Arduino, and I remember like finding this shit, and it's like, yeah, you need to use pins A4 and A5, and I'm like, well, I can't do that. I'm using those for the gyros. So then I looked up other ways, and that's how I landed on the shift register. But these are shared. These can be shared with 4 different things. So it's like, what? Fuck me, dude. All right. The best tool out there? Yeah, it is not bad at all. I just don't like how hard it is to add new things to it. Well, let's see. Let's see how good this is. Because I am going to add this thing. So I want this thing, not the chip, I want the module. And I need to add it to KiCad. To KiCad. I always want to read it as KiCad. All right. Resistors on the board says what address it is. So if you change the address on the second board, then you have 32 extra pins. What? Wait. Okay, I think I What are you talking about? It's slower than shift registers, but more flexible. Okay, okay. I'm still gonna use it because the shift register is not gonna work at all for what I'm trying to do. But is it good for inputs? I just wanna know if I can hook a bunch of buttons to it. That's all. That's all I wanna do. That's all I wanna freaking do. I don't think this is... Yeah, this is the chip. I want to... What is this module called? What is this thing called? Like, I want to search it. Shield? Ah, breakout. Oh, breakout. Yeah, that's what it is. The shield looked better. Oh, there's multiple. Oh god. Okay, I got this one. I just want a tutorial of the exact one I just bought. I didn't buy that one. What did I just buy? Jesus. I just bought this. I just bought this thing. So I want like a pin out Arduino tutorial, whatever, of specifically this. Oh, cool, and it also converts it to 3.3. That's interesting. Good. Good. Okay. Okay. But I want to know how to hook this up on Arduino. I don't even know what this... Okay. Is this the same thing? This doesn't even look like Arduino. Jesus, more than one thing with the same address. I feel like that's gonna be so slow though, but what do I know? All right, this has to be it, right? We've already seen this infamous picture, but that's fine. Why is there a B there? I can't read these pins. Oh my god. Yep, there it is. Oh wait. What is this? This is what I bought, right? What? What? Oh my god. This, yeah, that is what I bought. Okay. Why is this hard to find? Like, is this what I'm looking for? What, like, I guess that's pin 1? Or what is this? I can't read that, but whatever. Why are these, like, okay. It's pin 10. Why are we hooking pin 10 into the interrupt? No, that's pin 10. What is happening? Oh my god. Okay. This is not the same. This is not. Oh my god. This thing. I want a tutorial on this thing, please. This. I mean, maybe it's like, is it that? Maybe it's self-explanatory. That is very possible. But like, why are there 3 VCCs? Or this is VDD? What the hell does that even mean? So this is 1, 2, 3, 4, 5, 6, 7, 8. This is 16 pins. Apparently pin 8 and 9 just don't exist, but that's fine, I guess. Why are there grounds and oh my god. Okay, the grounds, it's all just ground. I get that, but I'm trying to like follow the traces. And then this one, okay, this is like master. I don't freaking know, dude. Use 2 of them and change the address on the second one. That's crazy. They can do both digital read and digital. That's awesome. Yeah. And then, like, why was that picture upside down for... I'd rather just look at the Amazon... Oh my god. I mean, this gives me a better idea of... Okay, alright. So we are, oh, really quick. Wagon, who is in the chat, he fixed all of the errors with my footprint. There were like 11 errors and like 30 warnings, and they're all fixed. Wagon, can I? Okay, search that library. I will. I trust that it works. I don't need it. But the one that you made, the new KiCad thing, is it safe to just delete this and then replace it with the one you made? Because, like... It appears to be exactly the same. There should be examples of it on YouTube. Yeah, I'll figure out the wiring later. Oh, man. Let's see. So, like, can I delete that? Or I guess I'll just remove it and see what happens. Did I just copy it? Okay, we'll delete it. And now let's open KiCad. And it can't find it. That makes perfect sense. So yeah, I mean, it's still, yeah, but the only difference is that there's no freaking errors or warnings. Right? Oh, okay, there's still warnings, but still, no errors. All right, that's awesome. Thank you. Still warnings. That's okay, though. Okay. Okay, so new plan. No more shift register. Instead, it's going to be the rotary encoder. So I mean, goodbye. Put that there. All right, Rotary encoder A. Rotary encoder B, which is D3. These should both be interrupt pins, as far as I understand. Oh. Wait. I thought F was flip. Is X flip? Okay, X is now flip. Okay. So now we've got the rotary encoder on both of our interrupts. We don't have we don't need that anymore. This is all fine. Instead of gyro X, it's just going to be called what? Just SDA. And then we need to update the gyro to reflect this. So okay. So as far as I understand, those are the two I2C pins. Yeah, no, you're fine. Yep. I remember that. And that wasn't a mistake you made. That was all me, baby. So I believe. How did I fix? What was the fix to that? Because the ground is on. Oh shit! I don't even remember. Wasn't the ground on the left? Wasn't this ground pin 3? Wasn't pin 3 ground? Is that? If I remember correctly. I don't remember. Yeah, let me know if you remember. I can look it up though. Okay. So the rotary encoder is now it now has dedicated interrupt pins. This is good. Did I do this? Yes, I did. Did I? I don't remember. No, I didn't. I just made it up. I didn't do this. What did I do? I did connect it to... Yeah, no. So what I did was I connected it to ground, and then just directly to the pin. But so this new pin is going to be the thing. Whoa. I want to create a new symbol. PCF857. But I don't think I'm going to be... interface expansion. This is it. But it's a 575. This is the 574. Does that matter? And also, this is the chip. I want the pin. Sorry, the breakout board. Also, this isn't even the right number. Reverse 2 and 3. Oh, so did I do it wrong? Oh no, reverse 2 and 3. That's what I think that's what I did. Yeah, that's what I did. Oh, but I didn't fix this. So yeah, 2 and 3 were reversed. Make the middle pin on the TO to 92V+. I do not know what that means, but I should be able to fix this. I think we could sneak this bad boy through here. There you go. Oh, what about this one? Nice. All right, how'd I do? It's pretty good. You're delayed like 30 seconds, so. Oh, maybe not. Yeah. We will make a new one. These are my libraries. Where, I forget how to add this shit. So we have added symbols and added footprints. This is a symbol. So do I just make it here, right? But I need to select a library. But I can't find my added... Oh, I guess I just put it under modules? Alright. Let's call it that. P. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10, 10, and 5 on the bottom. So it's 10 to 17, VDD, and then ground. Be easier if I just kept this up. How about that? Would this be bi-directional? That's how you did it. Nice. Okay. Oh, this is the wrong way. I want that to be, yeah, there you go. It's been a while since I made one of these. I mean, it hasn't been that long, but oh, and I guess it doesn't actually matter how I set this up as long as it has the correct pins and shit. Okay, so honestly, I could do like 0, 1, 2, 3, 4, 5, 6, 7, and then it just skips 8 and 9. Now we can set it up how it is on the actual thing. So we're going to 17, 10, 11, 12, 13, 14, 15, 16, 17. Okay. You guys miss KiCad? Because we're back. So I'm gonna finish this KiCad thing. I'm gonna fix the schematic, the footprint. We're gonna get the gyro working in real life, and then that's the plan. Next stream will be once I'm not streaming. I might stream tomorrow. Try to get the screen working. But I look forward to getting this thing working. That's gonna be exciting. Okay, my brain didn't work there for a second. That's interesting. I think it's because I was talking. Okay. I can't copy and paste that one. Well, I could, but I don't want to. Because all of these have a 0 in the front. Okay. Poo. I'm a child. Alright. VDD and ground. Does anyone know what VDD stands for? I don't know. Now, what pin number should this be? Oh, that's pin 8 and 9. Oh. Wait, no, it's not. I don't know. Is this power input or power output? Like, I have no idea. Oh, I guess we don't need the other two because they're the same. Oh, maybe VDD means it's output. Maybe that is output, and then VCC is input. Oh, shit. Okay. That makes sense. Okay. Okay, so in this case, I want all of the pins to be... I want them to all be on this side. And then I want the out... Or I guess these are inputs. I want the inputs here... Oh, they're all inputs. Things go into... Oh, frick. Maybe I should just put all the pins on the same side. I don't know. I guess it doesn't really matter. Like, it honestly... it doesn't matter. I'll change it if I need to, but... So we need these these four now. I do want to put this one here, though. I think it just makes it easier to understand. Maybe, we'll see. So this is power input. Well, this isn't just input, this is... I don't know. Oh, it's VSS? That's an S? There's no way that's an S. It's a positive. It's a positive supply. Where do you see VSS? Oh, they're all bidirectional. All right. Good. Looks good to me. Looks good to me. Cool. So this is good. This is good. Let's start doing the switches, I guess. Where was there a pinout for this? Oh God, I forgot already. I just want to see someone wiring this up that knows what they're doing. What the frick? This isn't what I have, though. Maybe it's the same. I just want a picture. Stop. I don't want a video. I can try following this, but no, these don't have the same pins. Oh my goodness. I can't even read that. Why can I not find a single... Oh my God. This is a shit. This guy's using the actual chip thing. Jesus. Can't wait to buy these in bulk. So cheap. I mean, how hard could using this actually be? What do? You just put the SCL into the SCL, you put the SDA into the SDA, and then you put 5 volts into the 5 volt. What about the int? Oh, interrupt. Okay. That's probably what that means. I mean, it's got to be that easy, right? I really just wanted to, like, I'm just looking it up to get a confirmation. Like, I can probably figure it out myself, which hopefully I just did, but there's not much figuring out. It's not that hard, but I really just wanted to see, like, a working version so I can confirm that I'm not doing it wrong, but whatever. So it could... I could look on YouTube, that's true. There will be example code in Arduino. Yeah, I don't care. I mean, the code I'm not concerned with. I'm concerned with, like, for example, do I need resistors? Do I need any capacitors or anything like that? Or is this good enough? So I mean, I guess we'll find out. All right, yeah, I want to put all of these on the same side. All of these on the same side. That is very handy. No idea if there's a quicker way to do this. I wonder, like, can I... I don't think so. I was gonna do it this way. Put ground down here too. Alrighty. Switch 1. Right in there. Joy button. Right in there. Wow. I don't need this, right? Do I need this shit? Can I set these as, like, pull-ups? Make this ground and... Oh, Jesus. Okay, basically you can think of it as an open drain output with a 100k resistor pull-up built in. But that's not what I have! Okay, but that's basically what I have. Okay, it's essentially the same thing. through. Here we go. Each pin can be an input with light pull-up or an output sync. I don't know what that freaking means, but if that means this can be ground and this can be ground, then I'm happy. And then I don't need this shit. I think that is what it. What the hell is a light pull-up? And then when you connect the switch, it pulls it down to ground. Or a light pull-up. What the frick does that mean? Oh, it explains it right here. Okay. Option 1, lightly pulled up input. Oh, that's not an output. Wait, input. I want input. That's what I'm doing. Input. By default, it will read as high, but connecting ground. Yes, that's what I want. Oh my god. I have been dying. That is, oh, Jesus. All right. Ground. It's high, connects ground, you're good to go. Jesus, okay. Ground, same thing. All right. What about the joy buttons? Same shit. Beautiful. Probably. I'm not actually sure, but let's just assume. Okay. Holy crap. Okay. Wow. This is good. This is good. I mean, is that it? Bumpers, back, but I mean, I might as well add freaking 20 buttons. Or, well, okay, maybe not 20, but more. Here's the joy buttons. So, I mean, let's talk about this. I wanted a back button for the UI. I also wanted a left and right bumper. Okay? For like, so think of like a video game controller. You got a left and right bumper with your pointer fingers. I mean, I could add like toggle switches. That would be nice to just have toggle switches. Where would those go though? Where would the toggle switches go? I guess it would be easier to just like look at this. Where would they go? We've got the joysticks, we've got the rotary encoder, we've got the back button. We've got two potentiometers, one on each side. They could go at the top of the controller or the side. The power switch I plan on having right here on the left side. Although the way this is set up, I can put it anywhere. Source means pull up. Sync means pull down. Okay. They work as the same way as digital pins on the Arduino. That's awesome. I mean, if I have like 2 additional like toggle switches, so like this thing, where would this go? I could add more buttons. I don't think I need more buttons, though. The 2 bumpers plus the 2 joysticks. I mean, where would they... I don't even know... Okay, instead of a back button, it could be a D-pad. Like, for like up, down, left, and right. That's interesting. That's interesting. It could be a D-pad. So here's where the back button is. Instead of just this, it would be like 4 of them. Because that way you could fully navigate the menu without touch if you wanted to. I mean, the top edge, we could, yeah. I wouldn't say it's wide open, but I was thinking the bezel of the screen, or I was thinking the screen would go right up to the edge with nothing above there, but we could definitely have some toggle switches. Yeah, I mean, just line it with like freaking 4 toggle switches. That's not a bad idea. Like 1, 2, 3, 4, just bam, 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 bam. Make the bezel of the actual case, or make the bezel bigger to fit it. I mean, we could do both. We could have 4 buttons here and 4 toggles here. I like the toggles. I think the buttons are unnecessary though. Not necessarily though. Cause like, okay, let's think about it. Like, what if I wanted to have a bunch of like animations or something, and each one is bound to a button? You can't do that with toggle switches, but you could do that with those 4 buttons. But the toggle switches would be cooler for like, oh, I don't know. What would we even use toggle switches for on this? Jesus. Oh, for example, one use for a toggle switch would be like gyro tilt on or off. So it would be like the hexapod would match the tilt of the controller, right? And obviously, like well, maybe not obvious, but in the code, I would make it so you could like program what each of the toggle switches do. So you could like set their functionality. I like it though. Four buttons down here. It doesn't even have to be like. I mean, they don't have to be in a D-pad in like a diamond shape. They could just be a row of buttons. There's most definitely room. So just like a row of buttons below the screen that are programmable. Joystick, joystick, potentiometer, potentiometer, toggle, 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 button, 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 button. We don't even need the power switch here. It could be one. No, the power switch should be over here. We don't want the power switch grouped in with the toggle buttons. That the toggle switches, that would be confusing. Okay. You put the battery under the display right in the middle. Like like this thing. Keep in mind this is on the bottom. So it doesn't really interfere with whatever's going on the top, except the pins, I guess, but I don't think... Put the battery under this. I don't think I can fit it under the display, though. Maybe. I haven't really tried to fit that under the display. Oh, it might, actually. No. I hear you, but it's just gonna go on the bottom. I don't want to put stuff under the display because like I just don't think that's a good idea. It can just go on the back of the PCB. It's not that big of a deal either way. Okay, I like this though. So bumper, bumper. Instead of back button, it could just be front. It's just button. So button, 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 button. Now, obviously, this pin's going to get in the way of that. This won't, but... You can also sandwich the PCB between an upper and lower bumper switch. True. That's very true. Although, I mean, the bumper switches, they were just going to be connected with wires. So it's not like... The bumper switches, I wasn't planning on having the bumpers be connected to the PCB. So that is irrelevant where the PCB is relative to them. But like, I could have, two bumpers on each side. That wouldn't even be that hard to do. I'm down for that. Like, I mean, at some point you can, I guess you can have too many things. But, I mean, is that really an issue? Like, look at the image of the KiCad folder. Okay. Is that really an issue? To have too many inputs on a controller? Like, okay, what are you talking about? Where? This is your folder, by the way. Well, it's mine now, but I'm confused. What are you talking about? What images? Look in the image folder of the KiCad folder. What do you mean? What is the KiCad folder? I'm so confused. I have no idea what you're referring to, but this is your encoder library. I will definitely check that out. Okay. You can screw mount the bumper to the PC. I could, but like, I mean, I'm just gonna mount it into the case. Like, what's the point of mounting it onto the PCB? I guess it would be nicer than using wires to connect it, but I mean, either way, it's not. I'm not super concerned with that right now. I like the two bumpers though. So we can have switch push. Okay, like sure. Left bumper. A and B, I guess. B for back. Sort of. Okay, we're definitely gonna run out of room here, though. But I love the fact that it's the size of an A4 sheet. Because like you could just print it so easily. We will make room. just delete the wires for now. Jesus. I almost don't like having the face buttons. I think just one is fine because, like, if you're controlling the hexapod, you don't want to take your thumb off to press a weirdly oriented button, do you? Like, controlling it. I mean, it's not that hard, but the bumpers are just so much easier to, like, interface with. It'd be nice to have the buttons, though. And it... Inside the RC transmitter folder should be an image folder. Alright, I'll check again. Where did you post it? Oh god. Okay, I don't know how far up you posted it or even where, but I did download it. Like, dude, this is... Oh, I can just check my downloads, I guess. Apparently not. This is it. This is your folder, so... I don't know... This was mine. This was my old one. Do you want me to... Is it in KiCad? Image converter? Oh. Image converter is cool. That's a good idea. All right. Well, anyway. All right. So bumper, left bumper A, left bumper B, right bumper A, and right bumper B. Do front and back. That doesn't really make sense. All right. This is cool. And then the toggle switches. Why did I use this? I mean, isn't a toggle switch just a switch? Like, can't I just use this kind of thing? Like here I did that, but and then what? I mean, what toggle switches am I even going to use? I'm not sure. This is my back button, right? Wonderful wires. That's possible. Yeah. I know I can make the sheet bigger, but then I won't be able to print it, and I definitely want to be able to print this. Did I move this? Shit. Hey, how do I click this? Oh. Wait, what? I don't know what happened there. All right. Anyway. Right, we've got our bumpers, and then let's just do the toggle switch. Not sure. I do want these. I want the toggle switches to be connected to the PCB. Because they can be. I just don't know. Because like it's using the pin header things. I mean, there's no way I'm going to be able to find, like... I don't even know... I'm not even sure what I'm looking for. Like, these are just buttons. Oh, lever. Something like that. Kind of. But this isn't exact. No, this isn't what I want. I mean, I'll have to just make it myself, probably. Because, like, I have... Well, I had. Yeah, I have this switch. I'm not sure if I want to use this exact one, but... I mean, it has two little pins... Well, didn't I... Hold on. What about this? No, that's just this thing. Yeah, which it's basically this, but slightly different. Maybe I just use this, honestly. It's just what I'm using for toggle switches, I guess. 6 amp. Yeah, that's it. But, I mean, I made this one myself, but... So, like, this is for... this is for the power switch. And then I want this to be... toggle switch 1. And then toggle switch 2. I want 4 of them. Maybe I put them here. Yeah, exactly. Well, yeah. Lasers drop. Yeah, just like actions, shit like that. Bumper switches where you can... Right. Yeah, headlight. Yeah, shit. Yeah. But like, it's tough because like I don't know. So it's nice to have, you know, the option because I don't plan on. I mean, I guess it wouldn't be. I don't want to have to redesign this regularly. You know, so. All right, all these grounds are connected. I think it would just be easier for me to just do this, and it would look nicer too. Pretty straightforward. So we've got the toggles, we've got the bumpers, we just don't have the buttons now. I mean, I'm gonna put the buttons up here, right? So. Maybe I probably shouldn't be wiring all this up, should I? It just makes things like super annoying. It just makes things like insanely annoying. Okay, let's just do this. Yeah, this is way better. All right, cool. Yes, the bumper switches do have screw holes in the side. Yes, yeah. So I plan on just screwing it directly into the case. I mean, I know it could go into the PCB as well. You can connect all those buttons with labels. That's what I plan on doing. Yeah. I think, if I understand what a label is correctly. Yeah, good. What's this thing called? That is quite verbose, but it is what it is. I don't know what else to name it. Maybe just PCF, would that be? I mean, I think if I just call it PCF, I know what that's referring to. I missed. Well, it's not D3 anymore. What does D3 even mean? Wasn't that supposed to be digital 3? That doesn't make any sense. Oh, I guess that's what this could be called. Just like just straight up P03. Yeah. Yeah, that's what I'll do. I'm not going to do the footprint today. I'm just going to get this hooked up. I want to get the gyro. I want to actually make progress with the gyro. So that's what we're going to do after this is all set up. Because I want to do something that actually works without struggling for hours on end. Because, holy crap. I feel like the gyro is going to give me that little win. Hopefully. Just happy to be doing something I know. Because, like, Jesus. Earlier it was not pleasant. Alright, we're hitting a little bit of an issue. The words are too long. Words too long. Okay, that's better. Hey, Juma, what's up? They'll stay attached to the PCB. That's a good point. That is a good point. If they're attached to the case, there'll be there's going to be wires going to it, and that would be super annoying. But why are we taking it out of the case? I say that now. To admire your work. No, it constricts the design too much. If I have to think like when I'm placing these bumpers in the case, if I have to be like, where's the PCB going to be in relation to this? I don't want to have to deal with that. The bumpers are going where they're going, and there's going to be a wire connecting to it. It's just, nothing else makes sense. Try using Control L tags. Whoa, okay. What is this? What, how is this any, what's the difference of this? Is it just a different look? I like it. It looks good, by the way. But it's too late. It's too late for that. Although, this is not good. I'm like staggering it. I'm running out of room. I mean, I can just move this to the left. Oh my God, my accuracy is not good. Alrighty, hopefully I'm not doing anything horribly wrong. This is, yeah. This is good. This is really good. I wish I had something to add to the conversation, but I kind of got lost in the research part that It's okay. No, you're fine. We're doing good, actually. So this is already connected. Ground VCC. That's it. Wow. All right. I mean, we've done it like this already. We might as well. P00, and then what is this? The rotary encoder switch. Alrighty. Just neatening it up a little bit. Trying to at least. So now, if I update this, it's gonna freak out. Yeah, well, not freak out, but like, so we've got our push buttons. We've got our bumpers. Now, we already had 2 bumpers, which is why there's only 2 additional ones. And then we've got our toggles. So I guess it didn't freak out. And then there's some other issues. So for example, our bumpers, we had them pulling up, but now we're pulling them down. Okay? If that makes any sense. So that's probably why we had errors. So these toggles are going to be, they're going to line the top, and we're going to extend the PCB upwards a bit. They're just going to be in the top center, I'm thinking. We could actually use the screen to label them if we're feeling crazy, but the bumper will, I mean, it'll be right next to this bumper, probably. The left bumper, it'll be right next to this. Right one's going to be next to this one. And then the push buttons, my idea was to just have them line the bottom of the controller. Something like this. Although I could make them in a diamond formation. I'm not sure yet. Could make them in a plus or in a square formation. I guess a plus formation, not diamond, but you get the point. I don't know, but I'm probably going to do this off stream. What I want to do now, I've saved it. I want to get the gyro working. So we have an MPU board somewhere. It's this. We've got this thing. I want to get this working. I'm choosing this because it's 1:40 a.m. and I'm pretty sure this shouldn't be difficult to get working. It's just like 3 wires. So we'll see. We'll see. Oh, Natalie's mad at me. I don't know what the hell she's doing. Hold on. What's going on? What? Why are you... Okay, don't shut my door. Okay, Jesus. Alright, it was a false alarm. She was just going to the bathroom. I thought I woke her up. You're not sure if it works the same way. Are you talking about the tag things or whatever? Oh, it doesn't matter. All right. So this is good. Let's see. I don't want this. Let's just go to this tab, I guess. This is the MPU Arduino tutorial. Now this is much more popular than the PC thing. Yeah, here we go. Here we go. This is what I'm talking about. I want it to tell me exactly what to do. All right. Oh, wow. Yeah, there's a library. I will install that. Don't worry. Okay, this is good enough for me. All right, so we just need these 4 pins. Oh, that's interesting. It can be used. Okay, that's interesting. I don't care. Literally do not care about that. So I'm going to this camera's so cool. Holy shit. I'm going to hook this up. This thing is no longer necessary at all, so that's great. Let's put this right here. Ow, frick. Holy crap. All right, she's in. Let's see here. So we want VCC. To be 5, I assume it's 5 volts. Yeah, it can be both. It can be either, rather. Ground is ground. These are obvious. Oh, it's already on. Okay. That's scary. All right, SCL and SDA. Here we go. So SCL, if, well, I mean, my KiCad thing shows me. So SCL is A5. I'm just gonna put that here. And so that must mean the other one is A4. SDA is A4, and that's all I need for this. Okay. That is wonderful. So we don't need the camera anymore. This should be a good way to end the stream, I hope. Did you connect the PCF symbol to the footprint? Oh. Oh yeah, I didn't make a footprint for this. I'm not doing that right now. I'm gonna do that off stream. I don't want to. Unless the only way I will do this, is there a footprint for the module? I don't even know what I'm looking for here. Let me know if it's in here. I'll do it right now, but otherwise I'm gonna make it from scratch. But yeah, this doesn't have a footprint yet. That's a good call. And then what about this thing? I mean, this shouldn't even be here anymore, right? This is the level, yeah, the shift register rather. Like that should have just disappeared as far as I'm concerned. But I guess I can just delete it, like. And then these push buttons are they're gonna automatically connect when they need to. Once I add once I actually add the PCF in. And then and then all these resistors just disappear. God, this is so much better. Okay. Yeah, there's a lot of work I need to do on this, but it's okay. I'm not sure. Whatever. Okay. I'm not sure if this button needs to be connected to ground or to 5 volts anymore, right? They're all pull down switches now, if that makes sense. It's just ground and the thing, yeah. So we'll figure that out. That's okay though. I'll do it later. Installing the libraries. All right, add a MPU 6050. Let's do this. Let's go to main. So we're actually gonna make a new. We're gonna make a new tab. All right, new tab. This is gonna be called Gyro. All right, and we are going to find the MPU 6050 library. Probably just. Oh, there's 2. Interesting. Well, now I'm scared. I don't know. I feel like I should just use the one the tutorial is saying. That is what I have. Oh. did indeed do that. Okay. I mean, I'm just gonna use this library for now. I don't think it matters. What? Wire? What does that even mean? Don't. No problem, Wagon. I need to do that too. Very soon, actually. And hey, I appreciate all the help. I really do. Thank you. If you're heading out now, have a good night, man. Yeah. Yeah. Best Arduino MPU 6050 library. I don't freaking know, dude. Should I just use... I mean, this one is named the MPU 6050. Oh, this is called Light. I do like the idea of it being, like, lightweight. Because, like, I'll have more room or something. I don't even know. On the Arduino. I only want the tilt angles. With respect... What the frick is wire? Okay, whatever. Maybe this is related to I2C. I'm not sure. Okay, so it's calculating it, and then once you start. All right, this is, yeah, okay. I like this, the light. I like this, although, I mean, what makes this light? Oh, gee, okay, 4 months ago, that's kind of cool. 0? Oh my God. I don't even know. Okay, I like the other one just because, like, I can actually read the code. These are weird examples. I guess I'll just click this one. It's auto calibration. That's interesting. How would they even do that? They do not use the interrupt pin in this tutorial. don't understand. Basic readings. Gives the angular velocity on the. Give the angular velocity, the acceleration. Okay, but I just want the tilt angles. I'm gonna go. I like this light one. It just get angles. Get angle. And it gives me the angles. I like this. I like this one. I don't know. I'm a sucker for it being simple. Look at this. Light. I like that. Let's get this one. All right. Sketch? Or what was it called? Where are the examples stored? Didn't it say, like... No, I'm... God damn. Oh my goodness. Just go away, please. Just go away. There was I was reading the tutorial. Oh my goodness. I don't even care. Whatever. Okay. So... What is get all data? All right, that's kind of cool. So you've got the acceleration, you've got the angle. Temperature. Don't care about that stuff though. For now, let's just do this one. I mean, I'm just gonna copy from here. I don't. Wire H. I have no idea what that is, but whatever. Okay, so we have our void set up. We have our loop. So let's convert this to what we need. So void gyro setup. I think is what I called it. No, set up. All right. Set up gyro. And we're just going to... Oh, we don't need the serial begin. We probably have... Whoops. So that should be here, most likely. And then set up gyro. No, serial begin. Wire begin. I don't even... What is this? What is wire? Do I even have that? Jesus. Wire data? Okay, it is I2C. That, yeah. Okay, I assume this is like a part of Arduino. So yeah, we can keep the wire begin here, I guess. Actually, I don't think we should. I don't think we should. We should put this in main, in my opinion. Because it might be used by it will be used by multiple things. So we can begin the wire, whatever that means, in here. Okay, and then set up gyro. We're gonna call it in our main. Okay. There's no code in here. Oh no. Oh, okay, because it's this. Okay. I'm just reading. Yep, everything is fine. This is all fine. And then in the loop, we're gonna call it void. Oh, not void. So I want to be able to get the X angle and the Y angle and the Z angle. Interesting. Okay, sure. So I mean, I could create. So I just need this to return 3 numbers, I guess. I guess we can make. Just have it return an int array of size 3, I guess. Something like that. What did I call this? Read rotary encoder. We're going to call this read gyro. Cool. All right. Don't need the timer. All right. Can I do this? Like, data of 0 equals this and print this whole thing? I don't know. Doesn't matter. Because I can just do this. I'm curious how this works. I guess we'll never know. All right. Alrighty. Oh, that's tab. Interesting. I think this will work. I mean, I guess we can just do gyro data. Gyro data equals read gyro data. And we're already printing. I don't really like putting the print here. Although, as a test, I guess we can leave it here. Okay, I mean, of course we get errors. Why wouldn't we? Read. Okay, well. I'm a little confused. Is this not a function? Did I do this wrong? It doesn't look like I did. Regyro was not declared. Did this... Can you not return an int array? I'm probably doing this wrong. There's a strong chance I'm doing this wrong. I mean, I could just directly set this. This is not, I don't like this. I don't like directly setting it like that, but better idea. Let's do this. I actually like this idea better. Read gyro and then string, or rather, and then you like input which angle you want, X, Y, or Z, and then it gives you that. Although, I mean, because theoretically, I don't want all of these. How do you, hold on, but I should be able to do this. Oh my God. Okay, we just don't need any of these tabs. I'm just gonna delete all those tabs. I don't like the look of that. Arduino, how to return int array. To return an array from a function. No, I just want to return a new int array. Not create an array, Jesus Christ. So you're in, oh, that's interesting. You're inputting the addresses and then just changing those directly. Okay, that's interesting. So could you do that with the array instead? Oh Lord, star. Oh God, don't get me started with pointers. I hate C++. Yeah, this is the remote for the Big Hex. I like, well, it's not just, I want this remote to be used for multiple things, but yes, that is primarily why I'm making it. I like actually hate C++. I am just trying to return 3 freaking numbers, dude. What is this shit? Like, why do I have to do this? I do not know why. I guess it's expensive. Okay, I guess. Now, if your array is really only 3 ints, then that argument does not apply. And you may reasonably want to return the whole array by value. Jesus Christ. Like, okay, I'll make a freaking struct, I guess. Holy shit. My lord. I'll make a struct. This is like obnoxious. Now I already forgot how to do it, so I need to freaking, oh my lord. Okay. Okay, that's not that hard. Although I'm not gonna do an array, because I mean, if I'm making a struct, why does it need to be an array? So I'm going to return a gyro angle data, which is just a struct with 3 motherfucking numbers. So gyro angle data. So let's make a new one. Am I doing this correctly? I feel like I am. Yes. Yes, I am. So, data.x, it's autofilling, that's good. Let's call it a GAD, gyro angle data, GAD. GAD.x, GAD.y, GAD.z, return, GAD. This, okay. Wait, where did I do that? Did I not update it? Oh, shit. Unbelievable. I forgot a freaking semicolon. Okay. Jesus. Yeah, yep, I did. All right. Here we go. Nice. So let's just upload it. Oh, I'm not even sure if I uploaded it before. All right. Okay. NPU status 0. Oh my god, it's working. All right. Are you guys ready for this? Oh my god. That is pretty cool. Not gonna lie. Whoa. Alright. And then if we put it back, of course the Z is just completely messed up. The Z is literally useless, by the way. Because it's not even like... I don't even know how they got the Z to be... I don't even know what Z is. What even is Z? The X and the Y, though, I mean, when I set it back down, it's basically 0. That's awesome. I'm hoping I can add some sort of like calibration for the, well, I don't even know. How does it calibrate? Oh, calc offsets. Okay, so let's make another function. Each one of these pages is basically, can I rename this? How do I stop this? Jesus. Each one of these pages is basically like how I interface with the specific input or output or whatever sensor. So for example, I want this to be void. Should it be void? Like, why? I guess the 1 second delay is just so you're like ready to set down the controller. So it's probably like instant. Void calculate gyro recenter gyro 0 out the 0 the gyro recenter calibrate gyro, and it's literally just going to be that. So I'm probably going to put this to a button press, but or maybe somewhere in the screen, in the menu. But this is good. This is good. So I don't want to print here. What I do want to print is in here. Let's think about this for a second. Previous gyro X. I just want an easy way to like print this. Okay, so if gad.x does not equal previous gyro X, serial.print, or if gad.y does not equal previous gyro Y, we're gonna do some printing. I don't care about Z. Z is literally just completely useless. Okay. In my opinion. So now we're only printing. Oh, hold on. We need to save. We need to set the previous now. So after we print, outside of the statement, previous X equals gad.x, because now it's the current, and then, because the current is now the previous, and then previous gyro Y equals gad.y. All right. Okay, now if we, okay. Did I forget like a bracket or something? Yeah, that is what happened actually. What do you want from me? GAC? Oh my god. It's capital Y, capital X. Okay, here we go. 2 typos. 3 typos. It's not plugged in! Alright, let's do this. The ancient tome has been uncovered. All right. So notice how that's not what I expected. Oh, whoops. Oh, wait, no, that's. Oh, there's no new line. Okay. I think that does it. I might have to do this differently, but I'm pretty sure that's what I wanted. Yes. Good. Okay, so notice how it was 0, 1, and then it was 0, 0, so it printed again, but now it's not printing anymore. It only prints if I move it. Only prints if I move it. Magic. Actually magic. And if I set it back down, back to 0, 0. That works really well. Wow. So, okay, guys. There's not literally a gyroscope in here. It's using the acceleration data to estimate the angles. But my god, it works like really well. So like, I've been moving it around. If I set it back down, it's back to 0, 0. Now, I bet I could like kind of get it off if I like shake it. Like, Maybe, we'll see. Wow, that's really impressive, actually. Cool. All right. So that's the gyro working. I have 2 things I can, like, I have access to. Because, like, I'm not going to be editing this code anymore. I'm not going to touch this. Well, okay, I will touch it to get rid of this shit because this is not what I want. But I have calibrate and I have read gyro. Read gyro returns a gyro angle data object, which is just X, Y, and Z. Okay. Frankly, you know what? Just to make this even faster, I'm getting rid of Z. I am never using Z. Z is worthless. All my friends hate Z. It's just completely useless. So we're getting rid of Z. Why? Because the velocity, like the sensors can't calculate it properly. I don't even know how it was calculating it, to be honest. So yeah. So XY, yeah, perfect. All right. And let's just make sure that still works. Yes, it still works. All right. It compiled. Cool. I'm just thinking, like, I don't really want this in main. It'd be nice to get, like, some sort of function that, like, returns a string that has this data or something. Same with the encoder. But I don't know. I'll add that later if I need it. All right, that was the gyro. That's awesome. So we can check that off. Test gyro. We skipped a couple things. I just wanted to do the gyro. So gyro's good to go. Unfortunately, we have some more stuff that we need to add. So create PCF footprint, update PCB to support the 4 bumpers, 4 buttons, 4 toggles, and PCF. That's it. Those 2 things. Definitely not doing that on stream, but I will be doing it. This is okay. We get to remove this. That's awesome, because we're not doing that anymore. We're not making the encoder work through a shift register. That was never going to work. Test joystick buttons, switches, and buttons in. So no more shift register. It's now the PCF. Specifically the PCF 5 something. PCF 8.5. Yeah, that thing. Just so I'm able to find this, I'm going to replace this with this. Test joystick buttons, switches, and button. Okay, test. Yeah, joystick buttons, switches. I don't even know what that's referring to. Toggles. Oh, the bumpers. That's what. Test joystick buttons, toggles, buttons, and bumpers in this. Okay. And then the joystick analyzer. That's easy, though. Then the screen. The screen is the big thing. That's going to be a doozy. I'm sure there is other stuff. I'm sure there is. I don't need this capacitor anymore either. Man, I mean, that should be good. You know what, now that I think about it, if I don't actually have this yet. So I can't do this test until they arrive. I just realized. I mean, no shit, but like, yeah. Once I get these and confirm I can get them working, and also once I get the screen working and like confirm my wiring works and stuff, I can order the PC. I can order this PCB. That's really exciting. I can order this. And it's gonna take like 2 or 3 weeks, but still. This is cool. All right. Oh, I wanted to update this. I knew I forgot something. I need to update this now. So what? It's minus 16? Jesus. But don't worry, so it's gonna be like buttons, quantity 4, bumpers, quantity 4, and then toggle switches, quantity 4. So now we're back up to 7 digital pins, and we only have 8. So, or 9 rather. But the encoder, digital pins 2. Or I guess it's, see, this is weird. It's 3, but it requires the interrupt pins. So really this is 7 digital, 2 interrupts. I think interrupt has 2 R's. 2 interrupts. We're gonna add, I'm gonna duplicate this row. Now I'm aware interrupt pins are digital, but whoops. That was weird. But I want to separate them. All right, so 7 digital, 7 digital. 2 interrupt, 2 interrupt. 8 analog, 8 analog. We are using literally every pin. I'm not even sure if that's right. I feel like are we actually using literally every pin? We have this one. I think I did something wrong here. Joystick 2. We can put this here. Bumper 4, buttons 4, toggles 4, rotary encoder, digital pins. Ah, there it is. Digital pins 1. There, okay. So we have 2 extra pins. We're gonna have 2 extra pins. 1 there. 1 there. I'm okay with not using those 2. That's fine. Holy shit. Alright, this is turning into a project. This is easily more complex than the Hexapod. The Hexapod's PCB at least. Alright, we're good to go though. I'm gonna call it here, guys. I hope you enjoyed the stream. We spent a lot of time on that rotary encoder, but although it was kind of in vain, it wasn't, because Wagon led us on to a new way to extend the pins, to extend like how many pins we have. The shift register was turning 8 pins into 3. The PCF chip is turning 0 pins into 16. And by 0, it uses the SDA and SCL, which are shared. So that's a win. It frees up the interrupt pins, D2 and D3, so the rotary encoder can just have control of those. And yeah, I mean, this is just a much better, it's not better, well, it's better because it works, but also like, it's just, there's so much more I/O. Like, we're gonna have 4 buttons, 4 toggle switches, 4 bumpers, 2 joystick buttons, 2 joysticks, 2 potentiometers, a rotary encoder, and a touch screen. All powered by the Arduino Nano. So we'll see if that can hold up. Hopefully it does, but yeah, this was great. I'll probably be streaming tomorrow. I want to try to get this screen to work. I know I can get bumpers to work. Whoops. But yeah, the main thing I'm concerned with is the screen. What else did I write in this? Jesus. Sorry, I was trying to push the chair in. What else did I write in this joystick, in this to-do list? Okay, that's gonna be off stream though. That I don't even have that. Okay, so we can do the joystick analogs, right? Like moving the joysticks. Oh, okay, the potentiometers. I forgot about that. Potentiometers, I mean, you just spin those. And then the screen. The screen is gonna be tough, but we'll see. I mean, maybe we do that tomorrow. Maybe we do that tomorrow. That would be fun. I don't know. All right, uwu anims. I'll see you later. Anyone else who's listening, I hope you enjoyed the stream. Have a great night or day whenever you're watching this. I don't know, but yeah, I'll see you guys later.